Bonjour à tous. On va pas tarder à commencer. On va laisser les gens venir. Une dernière personne arriver. Donc la réunion est enregistrée. Vous aurez accès au replay, aux slides. Les slides sont en cours de traduction, donc elles seront disponibles en français. On va commencer rapidement par un petit quart d'heure de présentation des actualités de la SNOMED CT pour 2026 en français, et ensuite on laissera la place à Noyen, qui est présente et qui travaille avec la SNOMED International et qui est responsable de l'équipe support à l'implémentation. Vous avez donc, normalement tous les micros sont désactivés, vous avez une page, enfin un onglet Q&R. Si vous voulez poser vos questions, n'hésitez pas, que ce soit pendant la présentation ou pendant les temps dédiés, on prendra le temps d'y répondre. Si vous voulez les poser directement en anglais, pas de souci. Si vous préférez, on s'occupera de faire la traduction si c'est des questions qui sont plutôt pour l'équipe SNOMED International. Je vais partager mon écran. Elisabeth et Emma, si vous pouvez me dire si on voit bien le...
Oui, on voit, oui.
Super. Donc l'objectif de ce petit quart d'heure, comme je disais, c'est de vous présenter les actualités ou les choses qui vont arriver en 2026. On s'est concentré sur 4 sujets. L'évolution du contenu qui est pas tant une nouveauté, mais qui est quelque chose qui continue et qui intéresse les utilisateurs. Donc ça nous semblait intéressant de vous faire un petit rappel, un petit point d'actualité là-dessus. L'Implementation Maturity Framework, qui est un outil qui a été développé par la SNOMED pour soutenir l'écosystème sur l'implémentation. Le forum des utilisateurs français et les formations 2026 sur la SNOMED CT. Donc en termes d'évolution de contenu, on a fait une enquête sur les SMT pendant toute la partie après l'été. L'objectif, c'était d'avoir un peu plus d'infos sur votre utilisation du SMT, votre utilisation des 4 grosses terminologies, donc la SNOMED, la SIM, la LOINC et le RIM. On a eu un peu plus d'une vingtaine de répondants et on avait notamment une question qui portait sur l'utilisation enfin, sur quelle hiérarchie côté SNOMED étaient les plus utilisées par l'écosystème. Donc on a réduit les résultats aux 10 premières. On voit que sur ces 10 premières hiérarchies, on a la clinical finding qui arrive en première sans grande surprise. Et ensuite, à égalité, on va retrouver les substances, les procédures, tout ce qui est médicaments, produits biologiques et les structures corporelles. Donc pour 2026, on a décidé de se concentrer sur les traductions de body structure, donc structure corporelle, pour 3 grosses raisons. Déjà, notamment sur le résultat de ce questionnaire, on voit qu'elle fait partie des 2 plus gros groupes de hiérarchie utilisés. L'autre point, c'est que l'ensemble de la hiérarchie est recommandé dans certains volets du CISIS. L'anatomie est utilisée de toute façon en SNOMED CT, enfin est représentée en SNOMED CT en France. Donc on va la retrouver dans l'imagerie, on va la retrouver dans les sites de vaccination, etc. Et on en voit aussi apparaître dans les différents projets européens. Et enfin, la dernière raison, c'était qu'on voit donc dans ces 2 gros groupes de hiérarchies utilisées, on voit les procédures et les clinical finding. Et ce sont des hiérarchies, des concepts qui vont réutiliser les concepts de la hiérarchie structure corporelle. Donc en traduisant ces structures corporelles, on s'assure déjà d'avoir un socle solide pour la traduction du reste des procédures et des clinical finding. Alors, ça ne veut pas dire qu'on fera uniquement des structures corporelles en 2026. On a évidemment les travaux sur les substances qui se poursuivent, qui sont notamment faits par Elisabeth, et les demandes d'utilisateurs que l'on pourra recevoir au cours de l'année. Là-dessus, justement, on voulait vous faire un rappel sur le portail RMP, donc qui est le portail des demandes d'évolution, qui a un peu changé avec la refonte des outils de la SNOMED. Donc maintenant, avant, vous aviez besoin d'avoir un compte spécifique, de vous connecter à chaque demande pour faire une demande. Maintenant, c'est plus le cas. Il y a le dashboard de la SNOMED. On vous remettra le lien dans le chat. Qui vous permet d'accéder à tous les outils, tous les services de la SNOMED avec un seul compte. Et donc c'est un peu plus simple. Vous avez aussi une refonte graphique qui a été faite. Vous allez retrouver le lien ici, le nouveau lien donc, qui a changé. Hein, l'ancien est plus valide. Euh, et donc si vous êtes une entreprise par exemple et que vous avez des produits qui sont vendus en France et aux Pays-Bas par exemple, sur le portail du RMP, vu que le Pays-Bas utilise aussi le portail RMP, vous aurez directement accès au portail français et au portail des Pays-Bas si vous voulez faire des demandes de traduction différentes sur ces pays-là. Et donc le lien est le même. Donc l'objectif du portail, c'est de vous permettre de faire des demandes de création, d'inactivation ou de modification du contenu, qui soit international ou national. Et ensuite, de notre côté, on a un outil de ticketing qui nous permet de gérer ces tickets. Vous avez le suivi de l'avancement de votre demande. Il y a toute une partie commentaires, vous pouvez revoir vos anciens tickets, etc. Et donc, on vous a remis, comme je disais, on vous a remis le lien juste ici. Et Elisabeth le remet dans le chat. On voulait aussi vous faire un rappel, on en a déjà parlé, c'est l'Implementation Maturity Framework. Pareil, vous avez le lien en bas. Alors, faites bien attention si vous l'utilisez. Donc, ça fait partie des outils de démonstration qui sont fournis par l'équipe support implémentation, donc l'équipe de Anne. Donc, les résultats ne sont pas enregistrés, il faut bien penser à les exporter à chaque fois. L'objectif de ce framework, c'est d'aider les utilisateurs de manière générale à superviser leur implémentation. Donc ça va aider à évaluer son implémentation actuelle sur différents critères qu'on va voir juste après, d'identifier les points qui sont améliorés et de pouvoir décider si on souhaite les améliorer ou pas, si la situation actuelle nous convient ou pas. Et donc de poser ensuite, de définir les étapes, la stratégie à mettre en place si on souhaite faire une implémentation progressive en se disant, bon voilà, une première étape c'était d'avoir tout l'outillage prêt et ensuite on va améliorer la partie formation et ressources par exemple. Et donc de définir une stratégie étape par étape pour améliorer petit à petit son implémentation. Donc ça se concrétise sous forme de questions sur différents domaines. Donc on va avoir des questions sur tout ce qui est gouvernance, stratégie. Alors les domaines euh, peuvent paraître assez vagues, puisqu'en fait la cible de cet outil, ça va être les pays membres et les NRC, mais aussi les organisations de santé et les éditeurs. Et les questions ne seront pas les mêmes selon la cible. Vous choisissez au début du questionnaire quel type de cible vous êtes. Les questions ne seront pas les mêmes, mais du coup les domaines évalués sont assez larges pour permettre de regrouper toutes les questions en fonction des cibles sous différentes catégories. Donc vous allez retrouver gouvernance stratégie qui va plutôt être utile au niveau des NRC, mais il y a aussi des stratégies côté éditeur, l'aspect technique, donc tous les outillages, les process que vous mettez en place, l'automatisation, etc. Tout ce qui est interopérabilité sémantique vis-à-vis de ce qui se fait dans le pays dans lequel vous implémentez la SNOMED. Formation et ressources, donc ça va être le niveau de connaissance de la SNOMED de vos équipes, les plans de formation, ce genre de choses. Adoption et utilisation, ça va plutôt être quelle partie de la SNOMED vous utilisez, est-ce que vous utilisez des fonctionnalités avancées de la SNOMED, le CL, la post-coordination, ce genre de choses. Et élévation et amélioration continue, ça va être tout ce qu'on disait sur une fois que vous avez défini votre état actuel d'implémentation, quelle est votre vision, qu'est-ce que vous pouvez mettre en place est-ce que vous avez mis en place des choses pour améliorer l'implémentation, etc. Donc ça vous permet soit d'améliorer l'implémentation, soit au moins de la caractériser et de voir où vous en êtes, euh, et d'avoir une vue un peu plus factuelle de là où vous en êtes. Troisième point, c'est le forum des utilisateurs français. Donc la SNOMED a mis en place ce qu'on appelle SNOMED Forums. Vous avez le lien encore une fois en bas à droite. L'objectif de ce forum, c'est de créer un espace d'échange communautaire entre les NRC, les membres du staff de la SNOMED International et les différents utilisateurs de la SNOMED, donc vous. Donc il y a différents groupes qui existent. On a des groupes de référence clinique, des groupes de traduction, un groupe dédié à SNOMED et Fire, des groupes sur plutôt ce qui est technique, des technologies, des logiciels, etc. L'objectif, c'est vraiment de créer un espace d'échange. Vous pouvez créer des sujets, discuter avec différentes personnes. Si vous avez des questions, c'est aussi un bon moyen d'atteindre les membres de la SNOMED International ou les membres de différents NRC ou d'autres utilisateurs qui pourraient avoir des utilisations ou des cas d'usage ou des questions un peu similaires aux vôtres. On a réfléchi du coup côté ENS à créer un forum des utilisateurs français, ce qui nous permettrait d'avoir un canal de conversation dédié avec vous, donc entre vous et l'ANS. Si jamais vous avez des questions, plutôt que d'attendre ces webinaires ou de passer par les mails, la communication est la dynamique est toujours un peu moins fluide par mail que par messagerie. Nous permettrait aussi de vous donner des informations. Des fois, on a quelques nouveautés qui arrivent qui valent pas forcément le coup de faire un webinaire. Mais du coup, ça vous permettrait d'avoir un échange un peu plus, enfin, un canal d'échange un peu plus spécifique. On communique pas mal sur LinkedIn, mais la problématique de ces réseaux, c'est toujours la même. Déjà, il y a les algorithmes qui font que vous n'allez pas forcément voir tous les posts. Si on n'est pas connecté avec vous, vous n'allez pas forcément voir les infos. Là, ce canal, ça nous permet d'avoir un canal dédié pour la France qui s'insère au sein de l'écosystème d'outils, on va dire, de la SNOMED, et donc d'avoir accès aussi aux autres canaux de conversation SNOMED. Donc n'hésitez pas à nous dire si vous êtes intéressé. On a eu un accord de principe avec la SNOMED pour créer ce type de forum dédié au pays. On voulait un peu avoir vos retours là-dessus, voir s'il y avait un intérêt sur ce sujet-là pour le lancer. Donc a priori, ce sera quelque chose qui sera lancé en 2026. On vous tiendra évidemment au courant du lancement. Et le dernier point, les formations SNOMED CT 2026. Alors pour l'instant, pardon, les dates ne sont pas arrêtées, mais on a identifié 4 sujets, deux sujets enfin un sujet qui nous a été qui est venu suite à une discussion avec la SNOMED, qui concerne la présentation de BAMNI, qui est un outil de gestion de DPI open source, qui implémente nativement la SNOMED CT, qui est la conséquence d'un accord entre l'organisation qui gère BAMNI et SNOMED International. Donc il y a pas mal de choses à présenter, de bonnes pratiques d'implémentation qui ont été intégrées dans cet outil. Et donc Kai, qui ne sera pas là aujourd'hui, mais qui fait partie de l'équipe de Hanoyen, pourra vous présenter cet outil, puisque c'est lui qui a participé au développement et à la collaboration côté SNOMED sur ce projet. Et trois autres sujets qui, là, nous reviennent plutôt de remontée de l'écosystème. On a eu des bons retours, des retours d'expérience, et on a eu d'autres industriels qui nous remontaient leur envie de participer. Donc, on refera sûrement on refera un retour d'expérience d'industriels qui implémentent la SNOMED CT, toujours dans cette dynamique de vous présenter des choses et que ce soit pas descendant de notre côté, mais que ce soit un peu plus horizontal. Et deux sujets qui nous ont été remontés par l'écosystème, le besoin d'avoir plus d'infos sur le format RF2. Donc vous présentez ce format, les outils qui sont développés par la SNOMED pour l'utiliser, l'implémenter dans une base de données ou autre. Répondre à vos différentes questions sur ce sujet aussi. Et quelque chose qui est un peu lié, l'inactivation du contenu. Alors Anne et Alejandro vont en parler un peu plus à la fin de ce webinaire. Comment gérer l'inactivation, comment les différentes versions. Mais c'est un sujet qui nous revient souvent sous forme de questions de votre part. Donc on voulait faire un webinaire là-dessus pour vous présenter ce qui est disponible, comment le gérer et comment, comment gérer au mieux ce sujet. Je ne sais pas s'il y a déjà des questions, mais sinon, n'hésitez pas à les poser dans la partie Q&R. Et s'il n'y a pas de questions, je vais laisser Anne prendre la main sur la présentation. So Anne, if you want to... You are in mute, Anne.
Yeah, you hand it over to me. I don't speak French, but I can guess some of the words that you say there. So, hi everybody, and thank you for having me at this session today, and thank you for joining. I have been looking forward to meeting all of you and to doing this session today. I'll just share my screen. I'm just trying to see here. Do you see my slide now?
Yes, it's coming. Yeah.
Good. Good. Okay. So thank you for your introduction, Maëlle, and also for all the good things that you are doing for SNOMED in France. It's really good to see that you have already decided on all the good stuff that you will be doing for the community next year. It will be great. But for the next few hours or 4 hours, we will address the topic of an introduction to implementation of SNOMED CT. And implementation of SNOMED CT is a very broad topic. So we have, of course, selected some of the things that we find are super important for you to know. And you may experience through this session that there are other topics that you would like to dive more into. Maybe we can have a discussion today about these topics, then you please let us know. But also, if there are things you would like to know about, please reach out to Maëlle and Elizabeth, and we can also add additional sessions on those topics. But today we will give you this brief introduction to implementation. And when we talk about digitalization of health, we often think about technology and electronic health records and apps and all the things that makes the digital health smooth. But the real foundation for all this technology is actually not the technology itself, it's the language and the way the information is communicated and used. And just like humans need a common language or a language to understand each other, digital systems need the same, a common way to represent clinical meanings. And that's exactly what SNOMED CT provides. It provides a global, computable medical vocabulary that ensures that meanings can be represented consistently and meanings can be preserved across systems and across countries and across contexts. So we have already started today's agenda with an introduction from the French NRC, from Maëlle, and now I will start then by giving you an introduction to SNOMED CT and a broad introduction to implementation. And in 1 hour or so, we will go into a bit more technical topic, which is on terminology binding, so how SNOMED CT works in an information model and how you link SNOMED CT to an information model. Then we'll have a break, and after the break, we will look at how to use terminology services effectively. And then we'll talk about how to query SNOMED CT and about how to using terminology services and queries in practice. And we'll give you lots of demonstrations as we go along. And at the end, we'll talk a bit about versioning and update. Hopefully we'll get through all of this and also have some time for wrap up at the end. Today, I will do the first bit of the talk, and after the break, Alejandro, my colleague Alejandro, will join us. He's still sleeping. He's in Montevideo, so it's still night there. But when he gets up, he will come in and talk for a few hours after the break. But as you can see here, we are 3 in the implementation support team from SNOMED International. We also have Kai Cooley, who some of you may have met at a previous session. But today it will be Alejandro and I who will run it. And our role is to support implementers on their journey to implement SNOMED CT and help to get as much benefit of the implementation as they can. That also means that we are here for you. So please always reach out to us if you have questions, small, big, anything. We can listen, and maybe we can give you advice, or maybe we can at least give you things to consider in your journey. So we come from SNOMED International, and SNOMED International is a non-for-profit organization that works to maintain, develop, and manage SNOMED CT. And the vision is for us that by 2030, clinical terminologies will be used globally, and that will result in better health and improved patient outcomes, supported by one language of health. So I think really drill a bit with the main objective of our organization, which really is to improve health and patient outcomes, something we all want. Regardless of where you are in the world, we want to make sure that we are healthy and that a country can function efficiently with as good health as possibly. And we believe that SNOMED, having one global language of health, is a means to get to that. And that's why we work hard every day to succeed with the management of SNOMED CT. I said we are a non-for-profit organization. We are also an organization that is owned and governed by our members. Today we have 51 members. These are the dark blue areas, but we also have affiliates, so places where SNOMED CT are implemented outside member countries. So that's also a possibility, and that's all the light blue areas that you see here in this map. So it's widely used and widely applied throughout the globe. In our organization, we are roughly around as many staff members as we have member countries, and we work in with different roles as in any organization. And I sit in implementation support. Some of you may also have taken our education e-learning courses. We have an education team. A key team is, of course, our content team, those who sit and author all the SNOMED CT concepts and make sure that the terminology has the content quality that is required. We have a strong technical team and a strong mapping team. And then we have our customer relations. And we have Licinio on the call today as well. And he's here with the picture. So some of you may recognize him from other events. But Licinio is really the contact point for France and for all the countries in Europe. So he is your main contact, and if there's anything, the Licinio and the National Release Center have a close collaboration. So there's an easy way, direct way to get into discuss SNOMED International and what we can do as an organization to help you better. And Licinio is the man to go to there. So that was just a bit about our organization and a bit about who I am. I can tell you that I'm based in Denmark. I have a background as a biomedical engineer. I've been working with SNOMED CT for many, many years. And also on the implementation side before I became a member of staff here. So that was a bit about me. Now I would like to learn a bit about you. So I will just present this one. Do you see? No, you still see my slide here.
Yeah,
do you see
the slides?
Yes.
Do you see now like a questionnaire quiz thing?
No.
No. All right. I'll just try to then share it. Stop share and share that again. It will.
If you have not selected screen sharing, you have selected software sharing, so you need to switch to.
Probably. Does it say thank you here? It should not say thank you. It should say welcome. So I will present this. Present. Good. You see it now?
Yeah.
Good. So I would like you to either use this QR code or go to ahaslides.com/SVODA. All right. Mael or Elizabeth, maybe you could put this link in the chat for me.
Okay.
ahaslides.com/SVODA. I can try ahaslides.com/SVODA. So that link I just sent there is the one to use. I will jump now to the first question, whether you have attended a training session before. So what I'm trying to understand a bit is about your level of knowledge on SNOMED. There will be a different question on that as well. But just to get a feel for who you are here on the call, so that I can target my presentation better. Okay. This is great. I'm always pleased to see when there are new people attending these sessions. I hope that you will learn or enjoy learning about SNOMED today and enjoy and get just partly as excited about it as I am. Okay. Good. So we have a good spread here. That's good. With the majority of having attended these sessions for the first time. So welcome here to this good community. The next question is how you will assess your knowledge of SNOMED CT. Are you a complete new? Are you, I don't know why. It's really weird that it's intermediate. The order here is wrong. I think I've set it to shuffle. But honestly, are you a beginner? Are you an expert? Or do you have somewhat intermediate knowledge or no knowledge at all? So the majority here is so no experts yet. When we run this again in a year, you'll all say we are experts, because then you will have been have your hands in it. So good, thank you for this. It's very useful for me. I'm already pleased about some of the slides that I have here, because I have included some background about SNOMED and some introductory material as well. So that's great. My Ellen Elizabeth knows this, and that is that I'm a Francophile. I love France. I often go to France in my summer vacations, and I'm so curious where you're based in France. So what is the distribution of you? And so you know that I will be coming knocking on your doors in my summer vacation. So I'm just curious to see where you're based. So it's actually quite a good spread. And we have 4 others. If you could put in the chat, maybe, I know if you listen, you're typing in, I know you're in Portugal, but maybe in the chat you could say, just maybe say where you're from. New Caledonia. Fabian, I don't even know where that is. Where is it? New Caledonia. Where is that? Oh, and from Belgium. Next to Australia. Wow. And you speak French?
It's a French overseas territory.
Aha. Okay, I didn't know about that. Sorry for missing that in my map. Thank you for that. I learned something. Very good. Thank you all. So, oh, I skipped one. Who are you? What kind of organization do you represent? So that's not who you are, but that's where you work. So what kind of organization do you represent today? So we have a new vendor strategy at SNOMED International. We really want to understand the needs of vendors and help them in the way we can. We know that vendors shouldn't have to revamp their entire system, but we want to help them to actually utilize SNOMED as a resource with as smooth processes as possible. So I'm just super excited to see that we actually have 11 vendors or 11 people representing vendors here today. So that is good to see. I keep jumping here. Your role in the organization you work for, what is that? I can assure you that these answers will not be used for anything afterwards. It's just for this session and for us to remember the attendance and where we were when we are going through this again at a later state. Fabulous. Looks good. So the majority of you are technical developers, some with clinical knowledge and terminology knowledge, and informaticians, implementation consultants, and others. So there is one mysterious one there with the other role. Happy for you to add anything in the chat if you want, but otherwise it's good. You can write this in French if you prefer, but about your expectations, what do you hope to get from the session today? Product manager. Thank you, friend. So seems like a good level to represent also, to understand managing a product and see if it's something you have to invest in terms of time, resources. Get an overview. That's a good practices of SNOMED users. Yeah, very good. General understanding. Learn about benefits. There should be, I hope that I will bombard you with the benefits of SNOMED through the session. Otherwise, let me know. I will get rolling on that. Understanding and the structure of SNOMED, have something on that as well. Basic knowledge on implementation, global knowledge on SNOMED CT and its implementation regarding medical devices, and lab results. Okay, that's an area I haven't specifically addressed, but we'll make sure that we'll cover something about lab and devices before we end. Thank you for that. General understanding how to implement, how it helped us scale. Yeah. Scale in terms of, can you add some words on scale in what sense? That you can reach out to more countries, that you can interoperate. So scale in the sense of something. Methodology of how to map with efficiency. Yeah, we do have resources for mapping. Again, it's one of the topics we haven't covered today, but I will make sure that we address that at some point. So it's good that you mention it. We have a very efficient mapping tool that can help people come with the codes that they are using in their systems and then to SNOMED. So it's very efficient when you migrate. So I'll make sure to show you that. Thank you for all of this. I hope that I can address and meet these expectations.
On the mappings. Sorry, yeah. Go on.
No, go ahead.
On the mapping part, there is a tool developed by SNOMED, which is Snap to SNOMED. You have access to the French edition, the 2024 French edition. We are working with CISRO, which are maintaining the tool, to have automatic update of the French edition. So each time you will log to the tool, you will be able to have the last version of the French edition.
That's great. That's very good. We will, I really hope that we will get to show you that. Otherwise, we'll show you where you can learn more about it and where you can access it and everything. It's something you don't have to, you can just start using it immediately. Very well. Thank you so much for this. It was super useful. Let us now jump to the presentation. And now I'm curious what you see again.
We are still seeing the slide.
I think I'm sharing in a wrong way today. It's weird. But hey, we'll manage.
I think you might need to turn off and turn on back the sharing.
What now?
Yeah, we are seeing the slides.
You see the slides?
Yeah.
Perfect. Good. Good. Okay. So until the break, I'm going to cover why standardization matters, about SNOMED CT design features. So those of you who want an overview of how the structure of SNOMED CT is, and just like an introductory understanding of SNOMED, that part will be extremely valuable for you. And then we'll talk about how you get access to SNOMED and the roles of the different stakeholders involved. And then we'll look at how SNOMED CT functions in a clinical system and look on data entry principles. And then we'll dive into terminology binding afterwards. So when we talk about SNOMED, we talk about a standard and we talk about standardization because standards are what's needed to make complex systems work together seamlessly. And I just want you to think a bit about your everyday life. When you plug in your laptop or you use your credit card, when you browse the internet, you rely on a number of standards without you even think about it and realize it. So without them, if we didn't have the standard, every connection would be different and it would be messy, it would be unsafe, it would be unreliable. And it's the same in healthcare. Hospitals, labs, pharmacies, all national systems, we generate data all the time. But unless we start to standardize how we represent that data, we can't truly share it, analyze it, or use it safely. So just as standards makes our modern life possible, standards are also very important for healthcare. Let us just talk a bit more about general standardization and think about electricity. That's one of the easiest and best examples of standardization. So imagine if every country or even every building, every hospital used different voltages or plug shapes or wiring colors. So plugging in your laptop would be difficult. I've been in sessions at your place in France, and that was possible because we were able to easily adapt between what we use in the various countries, or we even use the same. So you can say what makes electricity safe and universal is really standardization. And healthcare is similar. So you can say our data is similar. We generate this voltage everywhere, voltage in terms of clinical data, but we need these standardized plugs and power to make that data interoperable. And you can paint the image that SNOMED CT plays into that role. It's a standardization plug that lets health information flow safely between the systems. Another example could be road signs. So whether you drive in London or Tokyo, Paris, Nairobi, a red light always means stop and green means go. And You can again imagine, what if each city or country decided to define their own colors or their own symbols? You would easily get into a chaotic situation, especially when you have metropoles where there's so many tourists coming in. It would be chaotic. And again, the same applies to healthcare data, that if a hospital or lab system or a vendor, they defined the terms and differently. If one was saying heart attack, another said AMI, and another one said myocardial infarction, systems could not understand each other. So we need a way to standardize the meanings. So no matter how it's phrased, systems should really share the same understanding. And language, when we talk about it, is a common example of this challenge. So when we say use these different terms for the same thing, that all have the same meaning, you need a translatability of that so that we can understand each other globally. And SNOMED CT acts as that multilingual dictionary, because we have each concept linked to a unique identifier, a clinical code, and then we have many different terms that can be used to articulate that term. So this is why SNOMED enables a multilingual electronic health record system. And it also allows international data exchange, cross-border analytics. And you can say that SNOMED CT does not just translate language, it translates meanings. So all the clinical information you would like to capture in and around a record, SNOMED CT is designed for that. Another example is financial systems. So you use your credit card anywhere in the world, in a cafe in Paris or a cafe in Sydney. And the reason you can do that, many of you may remember the old checks. And I remember when we were going to France in my summer vacation, and my dad has to take these paper checks so that we can pay. I also remember him forgetting it, and it's a mess, because what would you do when you don't bring your money? Today it's so easy. You have phones, we have the cards and everything. And that's because we use these shared standards like ISO and EMV for chip and security protocols. And these standards are what ensures trust in the system. The ones using it knows what data to expect, what is coming in, and the banks knows how to process it. And healthcare needs the same kind of trust level and trust infrastructure. So SNOMED CT combined with the messaging standards like FHIR, HL7 FHIR, gives healthcare the same global reliability, and so that all the clinical transactions can happen safely between systems and follow the same rule. And I won't talk a lot about the internet, but that's also a very good example. And it's about knowing how the internet works. We have a way to protocols that moves the data packages. We have standards like HTTP and HTML to define how the information is requested and displayed. And then we have a set of APIs that you apply so that you can transfer the data that is relevant for that specific purpose. And you need the same kind of layered model when you implement SNOMED CT, where you have things like communication standards to move the messages and to represent the messages. And that could be a common standard today is the HL7 FHIR. And I'll show you different examples of FHIR later on. And SNOMED CT is really defines the meaning of those messages and what is said. So where the messages themselves represents the structure and the object, SNOMED CT represents the meanings. So without SNOMED, one system may use one term and another term, and then it would be fragmented if it would move without the context it's used in. But if you retain the context and you retain the SNOMED in the right structure and with the identifiers, you would actually, you can say you move the IP address of that meaning. So not moving just the terms, but also the concepts themselves. Then it gives the systems an opportunity to interpret what is said. So you can say that's what makes Internet of Health data understandable. So that was a bit about the benefits of SNOMED for those of you who said you wanted to know. I think this comparison to all the ways we need to standardize to ensure safe and reliable data is one of the key benefits. Because we live in a modern world where we use standards all the time. And it's funny because it's what makes everything work together. And in healthcare, it's a bit of a different story. Patient data, which is arguably one of the most valuable data that we have in the world, is often represented in some incompatible formats, and it's coded differently between organizations. It can even be trapped in unstructured nodes and free text. And the result is that we can't easily share the data, we can't reuse it, and we can't analyze it. So while most industries are very modern through standardization, the healthcare data ecosystem is still fragmented, and we really hope that this is something that we can together move forward in the years to come. And it's where SNOMED CT plays a role to close the gap in bringing healthcare data into a modern and more standardized world. Yeah. This is probably what I've just said. Instead of having these fragments of electronic health records that use different languages, SNOMED CT can provide a way to have interoperable, consistent data that can give us some reliable insights. I can't see if there are questions to this. As we go along, please just add questions to the chat.
There is no question for the moment.
Okay, thank you. So we'll move on to the design features. This is a slide that just speaks generally about SNOMED CT. That SNOMED CT is the world's most comprehensive clinical terminology or multilingual clinical terminology. The content of the terminology is scientifically validated and it's comprehensive. I'll talk about the comprehensiveness because it's so big. It's designed for humans, for clinicians, but it's also designed for machines. So it enables the consistent representation of clinical content for processing in electronic health records, both for processing, so it's computer processable, but it's also human understandable for clinicians. It involves many different, we see SNOMED as a hub and an integrator between all the various code systems that are used in healthcare. So there are many, we as an organization maintain a range of collaboration, and some of them involves maps and integrations of content. So we make sure that SNOMED CT can function efficiently with other code systems that are used. And as I said before, it is widely used. So a bit about how SNOMED works and the core components of SNOMED CT. If there are things you need to put in the back of your mind that you want to take away from this session today, if you haven't heard about SNOMED, is that what makes SNOMED CT function efficiently is the design structure, consisting of three main components. We have concepts, we have descriptions, we have relationships. And a concept is a clinical meaning, is a unique clinical idea that you would want to capture in and around a health record, whether you want to think about an acute myocardial infarction, which is a heart attack, or a necrosis of the heart. That idea, that clinical idea, or if you want to think about a laparoscope, the scope, the device you use in the laboratory, or whether you're thinking of a fall from a ladder, that someone is falling down a ladder, the event. So those things that are relevant to capture in a clinical record for some reason, because you want to accurately represent the meanings, all those ideas are represented with a unique identifier in SNOMED, and that's the concepts. To these concepts, we assign a set of descriptions, and the descriptions are the terms that we use. to provide the human readable or human understandable representation of those concepts. And then we have a set of relationships that links together concepts to each other. And these relationships are semantic relationships. So they represent a property or a defining feature of that concept that it relates to. So those three components are the core components of SNOMED CT. Here you have three examples of concepts: lung infection, lung, and X-ray of lung. They are three different concepts in SNOMED. Lung infection have a set of the terms associated with them. A lung infection you can call it lung infection, you can call it infectious disease of lung, you can call it pulmonary infection, and in French you could call it something else, which is completely fine, as long as the term you use actually represent the fact that there is an infection of the lung. Then we have relationships, and that's because SNOMED CT is designed to represent the definition of concepts. So what does a concept mean? And a lung infection has a defining property of finding site, the lung structure. An X-ray of the lung has a procedure site of lung structure. So we link together these relationships as triples, like there is a source, there is a relationship type, and there is a lung. And you can see the relationships here are too different. And that's because we have rules about what kinds of relationships can be used for certain concepts, so that we can always make sure that we represent the meanings of a concept accurately. And then we have a special kind of relationship that is used across all the hierarchies in SNOMED, and that's the ISA relationship. And ISA relationships forms the hierarchies. And here you can see that the first concept, the lung infection, is a type of clinical finding. The second concept, the lung structure, is a type of body structure. And then we have X-rays of lung, which is a type of procedure. And although you can have many ISA relationships, you can have many parents in SNOMED CT because you are a polyhierarchy, then each concept only belongs to one domain, so one top-level hierarchy. And we have 19 top-level hierarchies. I believe, Maël, you spoke about the 10 most important hierarchies, or you showed at least a graph with 10 hierarchies. But we have 19 top-level hierarchies in total in SNOMED. And it's really because SNOMED CT is broad. We have more than 360,000 active concepts in SNOMED. And they are divided into these 19 top-level hierarchies. And why is SNOMED CT so big? It's because the clinical domain is huge, and there is a lot of details that you want to capture in a clinical record. It's not only about disorders or diagnoses. It's not only about procedures. It's also about observations, about body structures, about stages and scales, about the objects you use. There's so many things that is important. And back in the days, we've been used to counting the incidences of a diagnosis and counting the procedures. But in essence, if we want to go into precision medicine and understand and make very targeted clinical decisions specific for a person, you need a lot more detail around a patient. And that's why we need a very broad terminology. Then we also have identifiers, and identifiers are associated with each of these components, whether it's a concept, description, and relationship. And the identifiers are like the IP addresses, or what did I say before? The unique identifiers to uniquely identify concepts, descriptions, relationships. When you store clinical data in the records, it's the SNOMED concept identifiers that you would store, because that's really the anchor of the meaning of a concept. There is some features of these identifiers. As you could see, they are numbers. It's not something that provides any clinical meaning. They are not intended for humans to read and understand. It's purely for computers. One thing you can be sure is that you can trust these identifiers. They will never change. So if you have a concept ID, that is linked to a certain problem, it could be an appendicitis, you would be sure that that concept ID will never start to mean something else. It will always be linked to that concept, appendicitis. And that's to support the full traceability. We don't delete identifiers in SNOMED. So if you can see a SNOMED identifier in a release, you can be sure that it will be there in 10 and 15 years to come. But what we do if something is outdated or if there is a duplicate in SNOMED or some error, we can inactivate a concept. And inactivation means that we don't recommend it to be used for future recording of data. You can still look it up, you can still use it for querying, but new clinical data should not use that concept ID, you should use one that is active. So that's a key principle. If you want to explore SNOMED CT, you should go to our SNOMED CT browser. You'll access it here on snomed.org/browser. And that is a tool which is not designed for clinical use. It's to support people who want to explore, well, how does the content in SNOMED look? What is within the allergy domain? How does SNOMED look there? And if you want to explore the various releases and editions, you can do that in the tool. If we have time at the end of this session, I'm happy to dive a bit more into the tool, but here is the URL for you to access that. SNOMED CT is designed, as I've said, to function as a standard and to support that data can be used. And there are different features of SNOMED CT that makes it useful or actionable. So where you go from recording information, you can apply the maps to other code systems. If you still want to use SNOMED for reporting and analytics, you can use hierarchies and the defining properties for more intelligent, explorative analytics. And we have a computable language that allows you to easily do searches and queries over SNOMED. So the hierarchies is where the ISA relationships comes in. Here you see a set of ISA relationships. And this is where you can say, if you record a bronchopneumonia in a system, you know that that is a type of disorder of respiratory system. And you can use those ISA relationships to automatically make aggregations. So if you want to count how many disorders do we have of the respiratory systems in our health record, we wouldn't have to identify each and every one of those concepts that are subtypes here. We can have a rule to say automatically, give me all the subtypes of respiratory system, and then it will identify the incidences for you. So that's how you can use the hierarchies. You can also use the relationships that we have. Here you see a concept, which is the malignant tumor of lung concept. And that is defined with a finding site of the lung structure and an associated morphology of malignant neoplasm. And these defining properties can also be used. So let me say that you have a set of diagnoses in a health record, and now you want to find those that have a finding site of the lung structure. You can generate a query using our query language to say, give me all the disorders with a finding site of lung structure, and then you can have it. Or give me all the disorders that have a morphology of malignant neoplasm to extract all the cancers. So you can use the subsumption tree, but you can also use the defining properties to create the queries. And the way you do that is using our computable language, one of the computable languages, which is called expression constraints. So an expression constraint is a query language that is used to filter and select concepts. You would use them often in terminology servers to say this value set should consist of all the diseases with an associated morphology of malignant neoplasm. A clinical user should never see these expression constraints, nor should the clinical users see the identifiers, but systems should be designed to use these features of SNOMED to function effectively. This one is around the different types of retrieval, the subsumption, the meaning-based retrieval, and the computable languages. I've already spoke to this about SNOMED being an integrator. So this is a visualization that shows that we have different collaborations with a range of international standards organization, and we provide linkages. Some of you may use LOINC in your system, and we have a new LOINC ontology, which allows you to query and analyze and code LOINC data using SNOMED. So when you record a SNOMED code, you are also recording a LOINC code, and you can use the features of SNOMED, which is very strong in terms of analytics, to query over LOINC using the design features of SNOMED. The integrity of SNOMED CT is one of the great strengths of the terminology. SNOMED CT is built on a description logic foundation. When I said we have so many concepts, it's not that each concept is placed in the hierarchy by a person. We define the meaning of each concept. So if it's a disorder that I'm modeling, I'm saying this is a disorder. It's located in this site. It has this morphology. It has this pathological process. There can be different features of that concept that constitutes the full meaning. And once I've stated that, we can put the stated definition into a classification engine that will then take that concept together with all the other concepts and make sure that the inferences are correctly based on how we define concepts. And so it's not that if you find that there are anomalies in the hierarchies, it may be because it's modeled incorrectly. And SNOMED CT is released every month, a new version. So there are means to easily go and correct things, but we are not making huge changes for things that are very stable over time. So we certainly don't change a lot of things. It's only those anomalies that we hear based on feedback and when groups agree that there's something that needs to be done in certain areas of SNOMED. Description logic is so powerful because it allows automatic way to detect redundancies in the terminology and inconsistency and make sure that concepts are placed correctly, but also to support the queries. We have versioning and change management. I said that we release it every month, and we have these identifiers. It's all part of the versioning design of SNOMED. We track changes and we version control everything so that you can go back in time and resolve if you have clinical data and you want to understand it, you can see there's something odd. The traceability of SNOMED CT helps you to resolve anything. Quality assurance is done through all the different parts, throughout the different parts of SNOMED CT that I showed you before, all the different teams. We contribute to the quality assurance. We also bring in the community we have a huge community that contributes to the quality of SNOMED CT from the translation perspectives, from the extension production perspective, and from the authoring groups and the clinical groups. We are all working together to make sure that the quality of the content and the design of SNOMED CT meets the requirements. Now a bit about the different stakeholders. So we are SNOMED International and we manage and distribute the international edition. Then each member has a national release center. You have the team where Maëlle and Elisabeth sits, and their responsibility is to support you as national stakeholders, but also to manage and distribute the national edition. And then you have affiliates. You are affiliates if you are implementing SNOMED CT and you have access and you have using SNOMED CT in your system. And affiliates can be anything from hospitals who have procured a system. It can be research centers that want to do research using SNOMED, vendors integrating SNOMED CT into their systems, and so forth. So affiliates will often use the national edition, but the national edition is built on top of the international edition. Just want to see if there was a question. You are just commenting, Maëlle. Thank you. Oops. When a national release center provides a national edition of SNOMED CT, they can do it by two means, either via a website. We have what we call the member licensing and distribution service. That's a mock-up from that. where you can download SNOMED CT. It's a release package. It's a zip folder. But you can also, in a country, provide it through a terminology server. So where you do a request, and then you can pull down either a value set where you do a partial export of some of the content. You may do a complete mirror of that server, or you may want to download the full release package, the zip package. And then the job is for the clinical systems then to be configured and enabled to use SNOMED CT in the system. I of course speak about SNOMED, and that's the main topic, but you can't speak about SNOMED implementation with also making this point, which is super important, is that on its own, SNOMED CT does nothing. Then it's just a zip package of many identifiers and terms. But in order to make it function efficiently, there are so many things that need to be considered. How do we govern SNOMED in our organization? What is our strategy for implementation? What are the prerequisites to make this happen? How does our technology use SNOMED CT? How can we integrate it into the places that we want? And how can we make sure that it's adopted by the end users? So SNOMED is part of the puzzle, but it's only a part, and it's not enough on its own. So these different bricks need to be included when you start to implement SNOMED CT. A high-level architecture is what you have here, that you would have a clinical system. It could be a health record. And here you have a data store where you record information about the patient, signs, symptoms, procedures, and tests, and so forth. You can then also have a terminology server. Sometimes that's an external server where you have all the information about the terminologies you use, all the information about codes and terms and the various content. It doesn't even have to be one code system. You may have a server with a lot of code systems that you use in the system. And then you link to the electronic health record to the terminology server through a service-oriented approach using a set of APIs. This is the recommended approach. Some system may also just load a set of files or load the data, the clinical or the terminology content into the system. But our recommendation is to use a server, but the other approach is definitely also useful and sometimes preferable, depends on the use case. The value of using a terminology server, and Alejandro will tell you more about that, is of course that when you have a service-oriented architecture, the same services can be reused in multiple systems, and it's really is in terms of performance and upgrading into a new version of the terminology, it's just easier that you don't have to go into the system and make the changes. So this is like the high-level recommended architecture. And if you sit there and think, oh, but our system loads flat files of lists and so forth, that's also doable. You just then need to make sure that the place where you create those lists to have access to the services required to extract that content that you really need, so that you don't start to extract everything. Because that's number one rule when you implement SNOMED CT, that clinicians should not have access to the whole of SNOMED when they record clinical data. You need a constrained approach, and I'll talk more about that. But now just a bit about the role of where SNOMED CT is used in a clinical system. And as you'll see here, it's used many places. You can use it to search and enter clinical data. And the benefit of using SNOMED is that you don't think in codes or think in a certain structure. You just type in or select the terms that match the situation. So you would do it as you prefer by using clinical spoken language that the clinician has been taught in medical school. Then you can use SNOMED to enable decision support rules and triggers. So say that if you have a patient that has an allergy to some specific substance, and then you prescribe a medication that has that specific substance as an ingredient, the computable language of SNOMED can be used to trigger, to say, if this diagnosis with this substance, then you would trigger an alert where this substance is the active ingredient of a pharmaceutical product. So you can use the defining properties of the concepts to actually determine decision support rules. You use SNOMED to store. You can use SNOMED to store clinical data. You can use the terms to store the display term, and you can use the codes to the, as I said before, the anchor of the information, the codes. You can then use SNOMED for knowledge sharing and creating clinical overviews that you use in your clinical care. So if you have a big dashboard with all the information, you can set up these easily to using the SNOMED CT to say, where are all the infectious diseases that we have right now? Where are all the different procedures that are done? And then you can, of course, use SNOMED to report to registers, either through maps to a classification system or using SNOMED directly in the registers. To interoperate with other organizations, other countries, and just other departments or other systems. And you can use it for management purposes, quality assurance or quality monitoring or population analytics and so forth. So SNOMED really supports the saying that you code clinical data once and then you reuse it for many purposes. So that's also what we illustrate here in this slide. So collect once and use many times. And use many times, it's not only for secondary purposes. As I said in the beginning, we are designing SNOMED CT to represent clinical meanings. We have a high focus on the clinical applicability of SNOMED. So it's also very much to support the primary use of data. When you implement SNOMED CT, it's not that you have to use SNOMED CT for all the things that I've just said. You can actually decide how you want to start and what you want to use SNOMED CT for. And that's actually a recommendation that when if you have a goal that you want eventually to utilize SNOMED CT for all these things, specify some refined projects and approaches, and then incrementally build on that. And that's what I said we in the implementation team are here to support you in. So please reach out to us and have a talk with us about what you in your organization can do to make most benefit of SNOMED CT from day one. Because if you want to do everything, it's probably not as feasible, or it's just easier to see that you did something and you succeeded in it, and then you expand and build on that. I want to show you some principles of data entry, because I said that before, that SNOMED CT is huge, and the main principle is that you don't give clinicians access to the whole of SNOMED. You need to constrain it so that it's only the things that are relevant for a certain context that you're capturing. And that's where value sets come in. So a value set is the set of elements that you have access to in a given situation. And you can define value sets using either a rule, or you can create a subset of things to say these are the things we want to access here. So if you have a field where you capture diagnoses, you should make sure that it's only subtypes of diseases that you record. If you have a data field for procedures, make sure it's only procedures. So that is the main principles of data capture with SNOMED, is that you make sure that you constrain the fields to the things that is relevant for that clinical situation. We don't dictate what is relevant. So what are the things that you should say? That's up to you, either in a national dictionary or in a local dictionary, to define these are the terms we want to have here, and the concepts we want to represent. And we don't dictate how you enter. You can design the user interfaces in any way you want, but you should make sure that each field is configured appropriately, so that if you have a set of 2,000 things that could be entered, well, then you use a search feature. If you have a smaller value set, you may have a drop-down list. And if you only have a few options, you can choose checkboxes or radio buttons, depending on what you're capturing. So we don't dictate what to say or how to say it. We provide the language and the quality, a high quality product that can support all these use cases. I want to just give you a brief demonstration of this. Now I probably have to unshare and share again then. Let me just EHR lab. Do you see my Google?
Yeah, we can
right
see
now?
you typing on Google.
Yeah, okay, so we can do that. Super. I'll just go to show you. We have a range of demonstrators, and in the previous sessions I've run with you, I've been showing you the UI demo, but we have a new one I want to show you today, which is the EHR lab. And that is a fictitious electronic health record designed to show some of the ways that SNOMED CT functions in a record. And you can go in there, and what you can see is that you can manually create some patients. You can also randomly create hundreds of patients. And then you can do different things. I'll just show you here one patient, Dorothy King. Just make it a bit smaller. So Dorothy King, there is some information about this person, and I'll just open the record. What you can see here is that there are some conditions for this patient. In the tool, you can show just how, if you capture things using free text, how you can identify some codes or main clinical concepts, and then you can confirm or reject which one to record. I'm not going to say more about that right now. I want to show you this problem list. This is an easy way to capture. You can see this patient has allergic asthma and a disorder of the vascular system. And this is also what is illustrated up here. So let us say that I was now adding a condition for this patient. Maybe she has a migraine. Over here, you can see that this field here is constrained to descendants of clinical findings. So I can't enter a procedure. Let us say that I was trying to enter a biopsy. Is a biopsy finding? Is a biopsy result normal? So you can see it's the result of a biopsy that I'm getting here. It's not the actual biopsy procedure. I can try to say it's a knee replacement. Then it's a loosening. So it's something that can happen. So it's the finding of the loosening. It's not the actual procedure. I can try to say appendectomy. Then it's the adhesions of appendectomy wound, so something that can happen. So I'm not able to record the actual procedures here. But if I am recording a condition such as migraine, you can see I get different types of migraines. Migraine without aura, ophthalmic, something with eyes, right? Migraine. I'll just record migraine here and add that as a condition. What you can see is that this is the concept ID. You would probably not show this in a record, but you can also see that there is an ICD-10 code through the map to ICD-10 that we have that is added automatically. And then I can add a medication. So let's say we will record propranolol. I think you do that. Propranolol. Propranolol.
It's P-R-A.
No, it's an O.
No,
it's an O.
O-P-R-A.
Like this?
No, R.
Pranolol.
Yeah.
Here we have it. Pranolol. Thank you, Elizabeth. So here I'm recording this propranolol tablet. I don't know if it's the right one, but it's something for migraine. And I'm adding this medication. Over here, you can see that's under my medications. Or what we could also see here in the bindings is that I can only record the clinical drugs here. That's what this says. I can't record migraine in this. Let's try to say migraine in this field. I can't, because that's only the medications. But over here, I can select the conditions. I can select that was for migraine, the one that we recorded. So now I've added this medication. What you can see up here now is that the system have one CDS recommendation. And then you can see there is a contraindication because propranolol has a parent condition or is a contraindication for the allergic asthma. And this knowledge that there is a contraindication, that doesn't come with SNOMED. That's for the knowledge producers. So those who are producing these knowledge bases to say, well, these medications has contraindications with these conditions, and all of this knowledge that's not built into SNOMED, but that's something that knowledge producers can use SNOMED CT to represent. So these various rules, the same with if you have different allergy, the allergy examples that I shown before. But this is really how the defining properties actually helps in creating very clever systems. I want you just to see how analytics could look. So if in a clinical record, you may have a set of patients, and then you can use the hierarchies. So this box diagram, there are plenty of ways you can use it. But let's see here in this box diagram, respiratory findings. And then you can see down here, 45 patients in my record here has respiratory findings. And here you have a division of the gender division and the age. And that's not part of SNOMED, of course, the demographics of these patients, but it's a way to use the hierarchy to filter. So let's see how many have a lower respiratory tract infection. And then you can see there are some, and you can see the age. And then you can dive into the individual patients. These are fictitious data, but it's really this diagram here is really built using SNOMED CT's hierarchical structure to easily navigate and filter your patients. Do we have any questions on this? So go in and play. Another demonstrator that I really think you should have a look at, which shows terminology binding, is the UI demo, snomed.org/UI. So this shows you where SNOMED CT is used for different parts of a clinical record. So you can go in and have a play with that. It also shows how when you use a standardized terminology server, you can swap between them. This uses the FHIR Terminology Services API. Yeah, so please go and have a look at that as well. I want to jump to the next part because I know that I'm running over time already. I want to dive in, and we'll have a break in 20 minutes or so. So I'll just go to the... So do you see the slide here with SNOMED CT and the information model?
Yes.
Yep.
Perfect. And Maëlle and Elisabeth, you will let me know if there are questions, right?
Yeah, of course.
Good. So now we'll dive into, we just spoke a bit briefly about the thing that you have to make sure to constrain data entry. And I showed you some examples of that. But now we'll dive a bit more into that aspect. All the benefits of doing this exercise with the standardization is numerous when it comes to health IT, and it's not a new thing. If you go into scientific literature 50 years ago, it was the same ideas we have about digitalization that is going to make the world of clinical or health IT will make health better. So we have so many benefits, anticipated benefits for this exercise. And often in the past, digitalization has been done in a way to please the clinical users to a huge extent. And I don't believe that we shouldn't do that. I do believe that we should please them. We should make it easy for them. But if you ask a clinician who has been using a certain way of capturing things for the past 50 years, and you ask them, how would you like it to be done tomorrow? You would probably get a response that looks very much similar to what they have been doing, because And I would do the same, because you like what you know. And sometimes you know what you know and you know what you have, but you don't know what you will get. So that's why we as implementers need to support them in producing some systems that make their life easier and better and smooth, and so that they don't have to re-document everything, and they don't have to use the same processes necessarily as they have been doing. And the point about this is also that if you just plug electricity into your papers or into the record as you have been using, you will have an adaptable system, something that they can recognize, but you may not achieve any of the other benefits you have in terms of data reuse and data sharing and decision support and all of this. So you need to think a bit more standardized, and maybe sometimes that requires that you have to cut a heel or something to make it the structure conformance to what is required to achieve these goals. Two parts of standardization that is important when you talk about SNOMED CT is the standardization of the language and the terminology, but it's also the standardization of the models, the information models. The terminology, the role of the terminology is what I've said in the past hour, to provide the vocabulary and provide all the meanings and represent them uniformly. The information model are used to capture the objects that you are recording and that you are representing in your systems. And it's used by different protocols and for different purposes. And I'll show you that in a
quick interruption,
second.
Anne.
Yeah.
We had a question about the demo from Fran. This demo you showed, are these services that come with SNOMED coding system to integrate?
These services that are used in this system that is all using the FHIR Terminology Services API. We have an open source terminology server that is called Snowstorm. Alejandro will tell you about that after lunch or after the break. And that comes with all the features that you needed to do the searching, to do the identify the properties, and all of these things. And Maël, you just added a link to the repository, GitHub repository, where you can find it. And we are also happy to run.
Sorry.
That's super. Thank you, Maël. And we are also happy if you get into this, to run some developer training where we teach you about these services in more detail than what we will cover today. So no problems at all. All right. I don't want to talk about SNOMED CT now, other than saying that SNOMED CT, and I want to repeat this point, it's to capture all the information, and that's why it functions as the hub. So it's a global language. It's global for all countries, but also for all different kinds of staff, not only medical doctors, also nurses and physios and any kinds of clinical stakeholders involved in recording information. And the model and the information models are how we represent and contextualize all of these concepts. This diagram here shows a range of different kinds of information models in different kinds of categories that we have created here. So, for example, models of use could be the user interface models. You have a way that you say, okay, I'm modeling my user interface in this way. When I want to capture a physical examination, this is how it should look with these controls. But then you also have a storage model, so the database diagrams and the models you use for the data store. And that may look slightly different from the UI, depending on how you set up your system. You may also have different storages of your data for different purposes. Then you have models of meanings. And that could be if you in France, let's say you have in France, you have a national dictionary to say, well, for recording rare conditions, these are the conditions you should use. If we want to report on communicable diseases, these are the diseases that you should record. And there may be national registries for cancer, different things that use some different models. And it can be national models, regional models. It can also be international models. EHDS is an example of this. So what is the information that we are sharing across all European countries? So that is a model of meaning. Then we have communication models, analytics models, and knowledge models. Knowledge models could be things that are used in decision support, where you link specific disorders to represent and medication substances to represent contraindications. So these knowledge models are other models that are used and can be utilized in systems to represent different rules. Analytics could be a model for how to easily query specific types of data for specific purposes. And communication models are models we use to share across the boundaries. Service models are like the FHIR terminology standards API. That is an example of a standard service model. So we agree on how we represent the specific services so that we can reuse them in various systems. Message models is about how is it we represent information about specific data objects that are represented in healthcare. And an example of that is HL7 FHIR models. And I'm not going to give you a course in HL7 FHIR, but what they do is they represent a set of resources. An example of a resource could be a patient. It could also be a problem or condition. It could be an observation. And then what they do is that they, for a patient, like in this example, they say, if you are recording information about a patient, what kind of information is that? There's a name, there's probably a gender, there is a telephone number, there can be a time where this patient is born, the marital status. So a group of people have sat down and agreed, when we represent a patient and want to share information about a patient through across records, what is the information that should be shared? And what you can see here is a set of what is called data items. There's an identifier for the patient, whether the patient is an active patient, the name, the phone number, gender, and so forth. And there's also a cardinality that will say, do I have to share this information, or does this information has to be present, or doesn't it? So there's always a cardinality as well. Here you see a procedure. It has many data elements. Of course, it's something about what is the procedure. There's a code here. The code represents the actual procedure. There is a reason code. So why are we performing this procedure? There is a body side and all of a range of other information, the status of this procedure that you can capture. And the same goes, there is a cardinality so that it's clear how you, whether or not you have to include it. And you can see there are other resources in, such as the performer or focal device, that links to some of the data elements. So sometimes it's not enough just to say the performer, but then you can go in to also share a performer details through a performer resource. Here is an example of the condition one with all the different conditions. So there is a code. What is the condition? A body side. Where was this condition? Where is it located? The onset, many other information about a condition. So that's 3 resources, but there are many other resources. For each of these resources, now we look at the problem or condition resource. The specification will tell you not only the cardinality, you can see that here, and you also see the different data elements or data items. And then you can see the type for that item. And where SNOMED CT is relevant is the places where you see codable concept. Codable concept is where you have specified a value set that can be recorded in that data element. Sometimes you may also have a text field. That's not the case in this example here. But if there's some places where you can add some free text, or here you can see there is an identifier. And here you reference to a different resource. But these codable concepts, so let us take a look at the body side. This is the body side for a condition. And you can see that is the description here is that you provide the anatomical location if it's relevant. And the recommended coding system to use is SNOMED CT. So here, this is actually a very high level binding that they provide to say what coding system should you use. And then you can be even more constrained to say, well, it's this part of this coding system that you should use. So the more detailed you can get in the bindings, the better. And if it was a user interface model, now it's a message model, you would probably say something about rules about when this is recorded in one field, maybe these are the value sets that should be populated in another field. So there may be other additional attributes that you want to represent in your model. But this is how a FHIR model looks like. And when you then record information and represent it, you can represent it as an XML. Many represent them as JSON, as we have it here. You can see in the coding part, oh, whoopsie. In the code, this is a condition resource. There are different elements here. I've made them bold. And in the code field for this condition, you can see that the coding represent what is the coding system. It's SNOMED. What is the code? That's the identifier. And what was shown in the user interface when this was recorded, it was ischemic stroke. No, the display is the fully specified name. So that comes from the terminology server. The text part is what was shown on the user interface, stroke. So someone recorded stroke. SNOMED says that that's the fully specified name for that is the ischemic stroke. And it has this identifier. And now you can then share this message to different systems that will then be able to say what was the condition of this patient, and they will know exactly where to look because it's a standardized format, and the receiving system may know this format, so they know exactly where to look to find what was recorded. And if this was French and you sent this to Denmark, I would see that this code was recorded with this, what would then be a French term. And then I would look that up, and then I could use the Danish edition to see, well, in Danish, that's because this patient had a hjerteanfald. And then I would know that. So the terminology binding is where you link the terminology to your information models. And terminology binding is where you really are careful with not saying, well, for this field, just use any SNOMED code. But you say, well, for this procedure, if you have a model for surgical procedures, well, then I only record things that are types of surgical procedures. If I'm recording allergies, I'm only recording allergic conditions. And why do you need that? Back to the clinical adaptability. If we want clinicians to easily find something, it helps them to easily do a search. And if you search in an allergy field, don't bother them with cancers and other things, just the things that that are relevant in that case. So it will make it faster, and it will also make it more accurate, because if you allow both disorders and procedures and substances, there is a great risk that they will record something that sounds slightly what they believe, but they may record a substance instead of a product or something else. So make sure it's the right parts of SNOMED CT that you're using. And that will increase the data quality, and it will also increase the utility. So when we do queries and analysis, they are accurate. We are not recording things that doesn't mean what we expect, and that's why it will also have an effect on data analysis. And it will make interoperability easier, just for the reasons I just showed you with the FHIR, that we can transform information consistently across the systems. I don't have too much time. I just want to show you the next part here. So what makes terminology binding difficult? And that's because when you have a terminology with the structure that a certain terminology has, now you know a bit about SNOMED and that the structure of SNOMED and the scope, it's very good at representing these clinical meanings. where the information models are good at structuring the clinical meanings. Then we have a middle layer, or a gray zone. In this slide, it's a yellow zone. And that's the situations and the contextual information. So if something is absent or present, or if something happened in the history, or if it happened to the mother of a patient. So there can be things that are certainties, if something is planned, or these things can actually be represented both in the terminology and in the information model. And that's where you as implementer need to think about how do we deal with these places where there are overlaps. Do we want the information to be held in the information model? Do we want it to be held in the terminology? And that will depend on the models and the purposes. So let me just talk a bit about SNOMED and context. So if we have a concept such as breast cancer, that's an easy example of how you can actually change the meaning of breast cancer depending on how you use that concept in your system. Let's say you have a field in your information model. Your information model here is an information model representing family history. And then you record breast cancer. Because you know the context or the model where you use this, you as a human can understand that there is a family history of breast cancer. If we use the same concept ID in a medical history field, then we would understand that there is a medical history of this patient of breast cancer. So this patient has had breast cancer before. If I'm recording the same concept in the context of a current diagnosis, I can make the interpretation that the patient has breast cancer now. So we've used breast cancer in 3 different ways to get 3 different interpretations. And that's why terminology alone is not enough. You need to understand the context, you need to understand the model in order to make the correct interpretations. And it's not as easy as that even. Imagine you have 3 systems that want to record family history, but you can actually do that in very many ways. Here are 3 examples. You can record breast cancer in a family history section. You can record a blank, you have a field, you just have a data entry field, you can type anything in there, and you do a search in SNOMED, you'll find a search such as family history of breast cancer. So here the terminology represents both the context, that is a family history recording, and the disorder is breast cancer. Here in System A, it's the model that holds the information that is the family history. Over in System C, we have 1 field for the diagnosis and 1 field for the family relationship, where we say, well, there is a diagnosis of breast cancer and it occurred for some person in the family. We could even be the mother or the father or who else had the breast cancer. So you can see there are different ways to represent the same information, and there are different ways to use the same codes. So when we are sharing information and using information, if we just focus on the terminology, because as you know, I'm a fan of SNOMED, I just think we should share SNOMED and then everything will be good. That would be naive, because if I sent breast cancer to someone else, what would they understand? They would probably say, oh, I got the information that this patient that I've received information from has breast cancer. So that would be inaccurate. So we need to share the meanings and also the contextual information. And the contextual information is often why you need that model. You need a wrapper. You need some model that is aligned between systems so that you know that I'm receiving a resource about family history and it's for this patient. And these models can be standardized models, they can be proprietary models, but it's really, really important that you use a model and that you use the terminology to then represent the semantic layer so that you can have accurate interpretation of your data across the systems. I don't have more time. You will have all these slides. There is a range of examples, and I hope that you can read through these examples And otherwise, just send me some emails with questions. I'll just go down to, there are some examples down here, 3 specific examples at the end. And there's also this sheet, when you see that in the handouts, it's actually to help you with what hierarchies you used for certain types of information. I'm just wishing through this because I want to show you that here's an example of how you can record allergies. And there's not a single correct way of doing it. You just need to consider what your approach will be. And there's also an example of malignant melanoma. So how can you record malignant melanoma? Are you using the morphologies or the disorders? And some examples of how you can do it. And there is a third example about procedures, how you represent whether a procedure is planned or done and so forth. So I think you should have a read through these examples, not in the break because you need a break now, but later on, and I'm happy to go through this in more details with you at another time. All right, so I will leave it here for now.
Thank you, Anne. And we are starting back in half an hour.
Yeah.
If I'm right. Yep.
Yes.
And as we mentioned at the beginning of the webinar, the slide will be shared at the end of the day, so we'll have everything to give it a look.
Yeah.
And we will see you in half an hour.
See you.
Thank you. Thank you, Jan.
Bye.
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 Maël, are you there? We will start the afternoon session shortly. I'm just awaiting Elizabeth and Maël because we need to get Alejandro in as a presenter.
Hi, Han, sorry. I hear you speaking, but I didn't add my headphones on the head.
All right, Alejandro is in as an audience. We need to get him as a presenter.
Yeah. He should be able to. Alejandro, can you?
Yeah.
Put.
I mean,
Okay, right.
Can you hear me?
Yeah, we're hearing you.
That's perfect. Okay, thank you very much.
Hey. Maël, do you think we're ready? Or should we give it a minute or two?
Yeah, maybe 1 or 2 minutes.
Yeah.
Let me see.
And good morning, Alejandro.
Good morning. Let me know if am I sharing my screen correctly?
Now we are seeing.
Yeah.
Yeah,
you're
sharing better than me.
Yeah, the first presentation.
Yeah.
Good.
And you have Kai's name there. That's great. And it's like he's here.
Yeah, he's present.
I have introduced our team. And we got to the point of terminology binding, showing terminology bindings in FHIR briefly.
Oh, that's good. Yeah, that's really good.
On va reprendre le temps que tout le monde revienne, on va reprendre doucement. Donc cette partie, c'est Alejandro toujours de l'équipe support et implémentation qui va nous parler un peu plus des serveurs de terminologie FHIR. Alejandro, if you want to start.
Well, thank you very much. Thank you, Maël, Elizabeth. And I will continue after Anne. Anne is the star of our education strategies, so I will try to make it up for you as much as possible.
I'll hurry up and shut down my camera after that comment.
Okay, so our first part, I mean, we have like 3-4 sessions in this section, but it's mostly oriented to the FHIR APIs, yes, and the practical use of these APIs in the SNOMED implementation. So we will start with these. If you saw a bit of this already in Anne's presentation, why terminology services, what's the relationship with SNOMED and FHIR and all that. So we some things probably you will hear twice, but maybe that's also interesting for people who are watching at this for the first time.
I haven't said much about it, Alejandro. Not much.
Okay, good. Okay, good. So basically, what are terminology services? It's a set of functions that give you access to the terminology, to the content of the terminology, and to all the features that the terminology system contains. Yes. So the idea is that enables you to use clinical data and to bind that data to standard vocabularies like SNOMED, LOINC, ICD-10, ERICS-NORM, and others. And the terminology server is the application that provides these services. The normal functions in a terminology server are concept lookup. You can get the concept to understand what are the details of the concept. A value set expansion that we will see a bit more about what's a value set and what the expansion means. You can navigate the hierarchy and you can map between different terminologies. Yes, validation is similar to lookup because it's like obtaining a concept and understanding if the concept is valid for a particular terminology. And why are we talking about this? Because it's important to have a standardized API interface to use these things. So we're using standard vocabulary, but also because the vocabulary needs to be incorporated into different systems, different software tools. If we have a standard API, that's much simpler because the developer can learn that API and then apply the vocabulary in different systems using the same API, or even apply different vocabularies in different systems, but using the same standard API. So it saves a lot of time and ensures consistency in the way the terminologies are incorporated into software applications. And also there are standardized query languages that these services understand usually. So when you want to do a query over a complex terminology like SNOMED, if you can use standard query language, that's much simpler. And the terminology servers usually have a lot of optimization because you are consulting the terminology servers in real time from your software application. You need that to be really quick and really performant. Yes. So when you use a terminology server, you concentrate all your optimizations effort in that application. And usually, when you use terminology server, you also get to learn from the experience of many other implementations. And one of those good experiences and shared good practices is just how to better search terms in the terminology. The search algorithms are not simple, but there are some techniques that have been applied for a long time in many, many different systems. And when you use terminology server, you get all this experience for free. You get these techniques already implemented, and you get these refined algorithms already working in the terminology servers. Also, the terminology servers are already prepared to be updated quickly. So like the point in your system, if you put your terminology inside the terminology server, there are a lot of utilities that are already prepared for a seamless update of the content of the terminology server. It's so much that you can even automate the update from national terminology updates and things like that. So if you separate these things, if you separate all this complex logic about query understanding, effective optimization, text, good best practice text search, and easy automation of updates, if you combine all that, it's interesting how you can separate that from your application and reuse that in a standard way using the terminology server software developed by an expert. So you separate those concerns. You say, I will work on the recording of the clinical data. I will work on the user experience. I will work in the data modeling on my side. But when I want to access a code and search for a code, instead of creating a table and looking into the table that I have in my system and do it all the effort myself, I can rely on an external terminology server. Yes, that is part of my architecture, and I can take advantage of that. So it's a good way to separate that. So there are different approaches to how terminology servers work. But usually the best and the most recommended approach is that each system, each clinical system, like an EHR, a laboratory system, or radiology system, or whatever system you have, should have their own terminology server. Yes, and this is like the most scalable one and the best practice for simplifying deployment and for avoiding for you to have a dependency from something in the cloud that you don't manage. Yes, we know we're having problems recently with Cloudflare and things like that. So we know that relying on someone else to provide a service sometimes is complicated, and many critical applications, especially in healthcare, want to be like self-sustained, to not rely on other systems. So the typical architecture will involve that each EHR will have their own terminology server, and those servers will download the terminology content from the same place. Yes, they are connected in some way, either by manual downloads and imports to a terminology server, or by an automated distribution using a syndication network. Though that content gets imported to each terminology server, and EHR can be developed querying making all the queries to a very fast, very reliable local terminology server. And that's not only for SNOMED, that can be for any terminology that you can put. Sometimes instead of having a site, yes, to download the packages and importing them to the terminology servers, sometimes what you will have is a national terminology server. And these national terminology servers usually have this syndication role. Not the systems usually don't access directly to the national terminology server, but the terminology servers can communicate with each other and can get updates from the national terminology server. Yes, but your EHR will look to the local one. Yes, you have a local one that is the one that is the one that would actually be used each time a doctor wants to search for something, or you want to populate options in a form, for example. But there is a national terminology server, and that can be used for this syndication structure. Yes. Of course, there is a possibility that when you develop a very lightweight application, you directly access a national terminology server. You have this reliability challenge in which you're relying on someone else for a critical part of your system, because when someone is working your EHR and you want to show something on the screen that is part of a terminology binding, you will go to the national server, get the options, and show the options to the users. You can have caches and things like that to prevent some problems, but it's a dependency that you will have. And this is usually not done for big systems, but sometimes you have like a patient-facing application or some small thing that has not very frequent requests, and you may make the decision to rely on the national terminology server. Not all countries provide this kind of facilities. Not all countries have a national terminology server to use in real time. But this is something that is a possibility that people can do. So at the end of the day, when you see how terminology servers are used, probably you have a mix of everything. Yes, you have a few that download a package from a national site, import in a local terminology server, and use it like this. You have a few that use the syndication network to get automatic updates. And maybe you have a few that have real-time access as well. There are some cases in which this is applicable, and this may resolve some issues. So I think you need to look to all these options to know that these options are available and to understand which one of these options is more interesting for you. Yes. So basically, when you want to choose one of these options, sometimes you want to consider what are the capabilities of your system. Yes, if you have a system that is really flexible and that is really modern, that you can change, you say, okay, now that I understand what the terminology server is, I will no longer use my codes table in my system. I know the codes are the terminology server, and I can really use them live. Even if it's my local terminology server, I can rely completely on the terminology server. So every time I need to code anything, I will go to a terminology server and search for value sets live using the API for terminology. Yes. And that's like the best practice that you can do. It's something that will resolve a lot of things for you for free, will be less effort, it will be really good. But sometimes you have existing systems that have some constraints. And so it's not easy to do this all the time. Yes, so sometimes you have a system that can use the API, but you have like an integrity check between the code that you use in the clinical record and the code that it's in your codes table. Yes. So if you have this kind of restriction, you can, instead of copying everything into your local table and search in the local table, what some systems do is they still use the terminology server to search, but when you select something in the terminology server, this is copied into the table and then linked into the clinical record. So you maintain that integrity between the clinical record and your local codes table. But the codes table is expanding every time someone selects something from the terminology server. if at some point you lose connection with the terminology server, you might still do like a search of the small set of the codes that you already know in your local system. So this is like a blended approach in which you use your local tables, but you use real-time search in terminology servers when they are available still, yes. But the last option is to say, okay, my EHR doesn't have any API capabilities. It's too complex for me to include a real-time API search. So if you can do that, but you can work with the database, what you can do is to update the database from the terminology server. Yes, because the terminology server has some capabilities, like we will show you, especially about querying and extracting particular information. So you can create scripts that will look at the terminology server, export diagnosis, and put them in the diagnosis table. Look at the terminology server, export procedures, and put in the procedures table, or export medications and put them in the medication table. So your system can continue to use these local tables like before, without using an API, but you have some backend script or backend integration that will extract information from the terminology server, take advantage of the query mechanisms, and they will insert the information in the database, and the users will only see the content in the database. Yes. So these are different like levels of integration, but the terminology server is useful even in the last one, when the users will not see the terminology server in real time, but they can take advantage of that for the updates of the data stored in the database. Yes. So in practice, what other of the advantage of a terminology server is that you can share the same terminology server with different tools. Sometimes you only have like an EHR, you have a terminology server for you. So in your container architecture, for example, you have a container with your application, a container with a database, and a container with a terminology server. Yes, or even the terminology server is like 3 containers that have the backend, the database, and things like that. So you can have that for your EHR, but also if you're in a hospital, you have your EHR and you have your PACS, your laboratory system, your another EHR for emergency, for example, something like that. You can say, okay, all these will share the same terminology server. So when I update the terminology in one place, everyone gets the latest version of the terminology. So it's useful also when you are scaling to complex systems. And the fact that the terminology services use standard like FHIR API that we will look in the next slides, it's something that gives you more freedom, more flexibility, and avoids lock-in. Yeah, so you can start with an open source terminology server, and at some point in time you decide, okay, I would like to have a commercial tool with some support and scaling and something like that. You can hire this new, or you can buy this new product, and you can just redirect your queries from one terminology server to the other, and it will work perfectly, even if the technologies are completely different, because they both expose the same FHIR API. So it's really easy to change from one server to the other. And if after some time you decide that you no longer want to pay for the service, you can go back to the free one without any complexity, because strictly, as in the same way we use standard for coding the name of a disease, we use a standard for these APIs. Yes, and this is the important thing. It's all about flexibility for you. So as you know, HL7 is Health Level 7. It's an organization that exists for like 30 years now around the world, defining different structures and models that are used to share information between systems. There's the first version I knew about was version 2. So there was a version 1 that I really don't know what's about. But version 2 was the HL7 messages that probably some of you may know, that they're used to communicate information between systems. These messages are a long string with separators that can be shared in different ways. It's just the structure of the message. This was really useful in the 80s and 90s, but in the 2000s, it was clear that we needed something with more expressivity. Just a long string of text with separators was not enough. And they created HL7 version 3. And version 3 was really complex. It's the one with CDA and all that. They have the RIM with the reference information model, which was a very complex information model. And it was really difficult to use. It increased the complexity a lot from version 2. And there were never like mature tools to deploy it. It was really complex to use. So when there was like a crisis where people were struggling to move to version 3 or to start implementing version 3, FIRE appeared. FIRE appeared from Australia. There was a person who works in laboratory system, Graham Reeve, who started to develop like a simplified version of HL7 that will be really easy to use and it will be more modern. Yes, and that's why FIRE was created. It's called Fast Healthcare Interoperability Resources, and it's completely based on JSON and REST, and it's a very easy way to share clinical content between systems. Yes, and when you look into FIRE, you have different modules. You have different levels, and the modules are organized in different levels. You have like a foundation module that defines how FIRE works, and this is completely open, XML, JSON, HTTP requests, and things like that. And then you have levels of additional complexity or application to the real world field. So in the level 2, we have one module that is important for us, which is the terminology module, which is one of the foundations of FIRE. Yes. When you continue working with these models, you can create the administration layer, the clinical layer, the diagnostic layer, the financial layer, things like that. And now the modern FIRE, the latest versions, you even have clinical reasoning and medication definition and all that. But we will focus today on one aspect of FIRE, which is the terminology model. So everything you do in administration, in clinical diagnosis, in medications, which use the definitions created in this terminology model. Yes. So the terminology model is part of this FIRE API, and it's a standard way to interact with terminology. So if this allows you to not only change terminology servers like we said before, but also change terminologies. So when you work with ICD, with 11, with ICD 10 or 11, with SNOMED, with LOINC, even when the terminology have different structures, you can still use the same APIs to access the terminology. Of course, there will be things you can do with one that you cannot do with the other because of the different characteristics. But the operations that you do and the way you receive the codes and the sets will be the same because this is standardized. So the terminology model is really simple. So it tries to say how we can represent any terminology. And the way to represent any terminology that HL7 designed is very clever and very concise. And it says there are three things that define a terminology: the code systems, the value sets, and the concept map. Yes. So the code systems are which terminology we are talking about, which is, for example, SNOMED, LOINC, or ICD. And the code system includes not only which code system it is, but also a version. So it's SNOMED from this date, this version of LOINC, or this version of ICD. But when you want to use this code system, you don't use it like a raw list, a full list. Usually you have two main use cases. And one of them is value set, which is a subset of the code system that is applicable for a particular clinical use case. Yes. So value sets is one of the main components of the code system. And the other one is the concept maps. Of course, the code system have codes inside. It's a list of code. But the operations are done at the code system level, at the value set level, or the concept map level. The concept map is the one that allows you to translate the code from one system to the other. Yes, and in theory, using these three resources, the value set, the concept map, code system, you can do most of the operations you need to implement a system in an EHR or any real-world clinical application. So the terminology model defines resources and defines operations. The ones we saw before are the resources. Yes, this is a code system, this is value set, this is a concept map. To access the resources, you have the operations. So the operations are the lookups, the validations, the subsumes in the code system, that is a special operation. In the value set, you can expand the value set, or you can validate if a code is a member of a value set. And the concept map has a single operation, which is a translate operation. Yes, because you have the basic REST operations, you can retrieve a code system, you can retrieve a value set, and you can retrieve a concept map and look inside. But also you can do like active operations with parameters inside each one of them to produce the results you want. So we're going to go through these resources. Yes. So if you go to a fire code system, yes, and you do a simple get to /code system, you get all the code systems loaded. Yes, and this works the same for value set and for concept map. This is one of the benefits of Fire being modern and embracing REST operations. Yes, you can just use it. If you want to have information about a particular concept, you do a get over the code system, but you do a lookup. And the lookup, all the operations in Fire are identified by this $sign before the root, the API root. So $lookup or pesos lookup, like we say in Spanish, it's the operation that will retrieve a particular code. Yes, so, and it has two parameters, because in the Fire server you can have many code systems. Yes, so you need to provide which system are you referring to, and which code you want to retrieve. Yes, so if you are not providing a version, only the system, the server will get you the latest version, or the one that is configured as default for that code system. So in this case, in the example, we are saying, in this server, in the code system resource, I want to do a lookup of this code in 222.98.006 in SNOMED. And what you see there as a system identifier is a URI. Fire uses URIs for identifying many things. In this case, for identifying code systems. So each code system has a standard URI that is shared between all the implementations. Yes. If you want to do the lookup to a particular edition of SNOMED, yes, for example, not the international edition, but the French edition, you can do SNOMED.info/ and the module ID for France, and you can use this URI as the version. So in this example, we're saying, look at SNOMED, that's what you have in system, and in this version, which is very similar URI, but has a module ID at the end. If you have a French terminology server that only has the French edition, you can use it like we said before. You don't provide any information about the version, but the terminology server will serve the French edition because that's the only one it has. But if you are in a terminology server that contains different editions and you want to point to a particular one, you can use the version parameters. Yes, and for that you use the module ID. The module ID is like it's a concept in the terminology that is used to mark all the concepts that are related to that edition. Yes, for example, the French edition creates, let's say, 100 concepts that extend the international edition. Those 100 concepts will be marked with this ID. And when you use this as a parameter, you're looking at everything from the French side, because there's a dependency between modules. So you will see the French content plus the international content, and that will be served for you in the terminology. So this is a URI standard. The URI standard says, what's a SNOMED CT in general? CT is SNOMED.info/SCT. How to refer to an edition is you add the module ID. Yes. And this is just when you start referring to an edition or an edition version, this URI is a version URI, not an edition URI. And then you can refer to edition version. You have the module ID /version and /the date. In SNOMED, we use these dates to identify the release date of the terminology. So you can use these to refer to a particular version. So this is the part of reference sets. I think we are, yeah, I'm looking at the time. I think maybe you need to go a bit faster, but we will do it. So if you go to the SNOMED browser, yes, there's a concept called reference set. If you search for reference set or simply type reference set, you will find this concept. This concept contains, especially if you go to your national edition, you will see your national reference sets or the ones that are included in your national edition. Or there's a derivative browser that is a package that contains all international reference sets. So when you go there, you see all these concepts that are not clinical concepts, because these are not clinical findings, these are not procedures or medications. These are metadata that is used to group different concepts. So you have an odontogram reference set, you have a general practitioner, family physician, health issue reference set, or you have the IPS, International Patient Summary reference set, or a nursing health issues reference set. Each one of these are collections of concepts in the terminology that have been collected with a particular goal in mind. Yes. So when we talk about these, we have different words, but actually they all mean kind of the same. A ref set is the structure in the SNOMED terminology is called a ref set, but it's a subset of the terminology. It's a functional subset. Yeah. So subset is a word that you can see somewhere. This is a subset for nursing, or this is a ref set for nursing. It's equivalent. Ref set is a technical representation. A subset is a functional representation. Yes. And when these things need to be represented in FHIR, they choose a different name because of these complexities, and they chose the name value set. But they all mean the same. Yes. A value set, a subset, and a ref set are the same, but they are different optics. So when you want to access a value set with SNOMED CT content in FHIR, there are different ways to do it. You can assign a value set with a special URI. You can say, I do a post in the server, and I create a value set and assign my own URI with 3 codes, and this URI will forever identify my subset. It's something that the structure that you create specifically in the terminology server. But there are other ones that are called intentional. And intentional value sets are value sets that are created using some logic. They are not created in the server, but you're allowed to extract as a value set content that is already loaded in the terminology. And you have 3 examples of how to do that, these implicit value sets. You can do it using an existing ref set, like we show you here. If you want to access the odontogram ref set, you can look at the ID of the odontogram ref set, and you can use this keyword. You can say, I want to access a ref set that has the same URI as the version of the terminology, plus FHIR VS, which is a magic word, equals ref set / and the ID of the ref set. And if this is the ID of the odontogram ref set, you will be retrieving everything that is a member of GP or P or odontogram or something like that. There are other utilities. For example, instead of using an existing value set, you can obtain as a value set something that is part of a hierarchy. So you can say everything that is below this concept in the SNOMED hierarchy, I want to retrieve it as if it was a value set. So you can send the parent ID and use the keyword ISA. Yeah, this, and you will get all the concepts that are descendant of this concept that you're providing. Or you can use a more powerful tool, which is to do one SNOMED query. The SNOMED query will be like an ECL. We have some information in the ECL before. And these 2 are equivalent, the ISA and the less than, the same ID. They have the same effect, yes? But the operations in the query can be much more complex. You can do set unions, you can do matches on different refinements. You will see the ECL is much more powerful. So in this basic ECL are equivalent, but you can go much deeper in the ECL to do that. So in order to do this, you need to use an expand operation. Yes, and the expand operation is the one that will get you a value set that is identified by the URI that you have. Yes. So for example, this is an expand over this version of SNOMED will get the default version of SNOMED, and it will get the content of the ref set 816.08.0008. And the display language will be English, and the filter would be SWEL. The filter is something that will allow you to do a text search. So when you expand something, sometimes you don't want to see the whole ref set and then do the filter locally, and you want to do the filter in the server. The ref set may have 10,000 concepts, so you don't want to retrieve everything and filter yourself. You want to do that on the server. And one of the filters is the text filter. And this text filter is interesting because it's the one that contains all the logic for matching. Yes. So in this other example, the expand operation is using the complete SNOMED, for example, because it uses Fire VS without any parameter. You're looking at the whole terminology as if it was a value set in English, and the filter is Mayo plus invert. Yes, and this we will see all these operations. We will see it in the next presentation. We will see them live in an application. Yes, so first we will see it here in the as a document, and then we will see it live in the browser. You can see how we are using parts of the words in the filter, like Mayo invert. Yes. Because you're using a terminology server that is compatible with Fire, it follows all the best practices and recommendations. And Mayo invert will match every concept that contains any word that starts with Mayo and any word that starts with invert. So it's a way in which you can leverage these abilities of the terminology server. This is the same. This is a URL. It's an expand operation over a Fire value set that is defined with the results as an ECL. Yes. And this is how you search, and you use the filter, and the search behavior that we recommend, and the search behavior that is implemented in most terminology servers is the one that uses multiple word prefixes in any order. Yes. So the example will be blood oxygen pressure within reference range. If you want to match that, you can do blood ox within. Yes, and that would match the concept below up there, for example. So once you teach your clinical users to search in this way, it's really fast and it's really easy. And because you can use the beginning of the word, you avoid doing like spelling errors, and you avoid variations of the same word, numerals and things like that. And the last operation we will show here in the documentation is the map operation. And the map operation is basically the three columns. You say, I have this map, the ref set ID is the map that identifies the ref set that contains the map. And it has two columns, like a source and a target. The referencing component ID is the source, and the map target is the target. This is how the table looks like when you see it in the terminology. But when you see it from the Fire API, you have the translate operation. Yes. And the translate operation says, I want to translate this code from this system in this version, and I want to translate into this. So for example, we're translating the code, the SNOMED code 2541530009 from SNOMED, from the French version of SNOMED, into ICD-10. Yes, this is how you do it. When you want to actually do this in the real world, yes, but you will do all these. You will have the system that has an EHR. You will use terminology server in different operations that you do to gather information for data entry, for analytics. You would use concept maps and all that. You will be guided by some implementation guides. Yes, when you're designing your system and you're making your system compatible with Fire, for example, you will have all the different fields that you need to represent in your system. For example, these are the fields that represent a medication. And every time you have something like the medication code, you have some information about how the code should be represented. Yes. For example, this is an implementation guide for medications that says in the IPS, in the International Patient Summary, that says these are the recommended bindings. The primary binding will be the medications in the SNOMED, and this is a value set. This is a preferred binding. And then you have additional bindings. You can use also for this field, you can use medication from the free set of IPS, or you can use ATC codes, for example. These are different bindings for the same level. These value sets, when you are working in a clinical record, usually you are restricted to, you're guided about which values you will use to fill a field. Yes, to search the correct terminology codes for a field. And you're guided by this terminology guide. The terminology guide will tell you what you need to do in each one of these. And the terminology servers are prepared to understand these guides. Yes. So when you have a terminology binding like this, you have a logical definition, and the logical definition says, for this field, you can use all the descendants from pharmaceutical products as normal, but excluding the vaccines. Yes, and all this information is contained in implementation guides. And the good thing is that you can use this in your system to validate if your system is collecting the right information. After doing all this operation, what you have is for each one of the resources that you're creating in your system, because even if your system has its own database structure, sometimes you need to convert your model into a standard model. You go from your medications in your database to a standard medication or standard condition. Like this example is a fire condition example. So in that fire condition, each condition is each problem, in medical problem or clinical problem of a patient, they have a code. And the code can be selected from a set of codings, and those codings are defined in the implementation guide. And that implementation guide contains the restrictions, the parts of the terminology that are allowed for these. So in this example, we have multiple codes for the same condition. We have the ICD-10 code and the SNOMED code for the same condition. These two codes have the same meaning, maybe with different level of detail in some cases because there are different terminologies. These are the levels of detail. We extended a bit more than was planned, but I think we can do a bit of the real world examples. Maybe we can go here and then we go back to ECL to do it in the right order.
I think it's okay if you just go to the
so
browser.
This part is a part in which we show you the terminology servers how working in the real world. And if you want to see examples of this, we have a tool, which is the implementation demonstrator. If you go to the implementation portal, implementation.somed.org, in Showcase, you will find the demonstrator section. The demonstrator section, we have all these demonstrators that are clinical applications that work with a terminology server in the background, the FHIR terminology server. So, and the good thing is that this is a completely open source project. We use the terminology server everywhere, except a few exceptions that's really difficult to use, but most of them use the terminology server. You will see a representation of most common use cases and challenges. All the demonstrators have some experience, are based on some clinical experience, either by a clinical reference group in SNOMED, or a problem that the country presented to us, or something that we need to do for a webinar or for a workshop. And usually some of the demonstrators are complemented by a SNOMED implementation guide that contain additional information for the demonstration, or even file implementation guide. So this is the site, yes, and we will show you the site. Let's do the demo here. I think you can see the demonstrator now. This is the demonstrator site. You can go here later. Each one of these has different examples. There are a lot of them, but let me show you, like the basic one is the clinical user interface demo. Yes, if you click there, this will open for you. This is a representation of a simulation of a clinical record, yes, that has these 3 or 4 fields that are important. This simulation has a reason for encounter, a diagnosis, a procedure, and maybe laterality in some of the cases. Each one of these fields is connected to SNOMED. The ones that have DS are fields that are connected to SNOMED CT. And when you click on the information fields, you have how they are connected to SNOMED CT. And they're connected using an ECL, using this language that contains all these operations that say, if this field is connected to all types of clinical finding, and or all types of procedures, or all types of situations, or all types of events. All these are the valid ones. And this one, the diagnosis one, are only clinical findings, and the procedures are only procedures. And you can see this here. So if I type here, I would put abdominal pain, but I know that this is using the advanced text matching technique. So I will do pay ab, for example, something like that. And I get abdominal pain as a first match. And this is one of the benefits we've been talking about. We are using all the capabilities and the text matching algorithms from the terminology server to find these operations. Yes? So I can click here and I select the concept. But what's happening here? If I click, open the console, yes, I can see these are all front-end demos. So everything that you see on the screen is being requested directly to a terminology server on the back. There's no other backend. It goes from the screen to a terminology server. And this is intentional to simplify the explanations. Yes. So I will do it again. So if I do pain ab, something like that, I get this. And if I see here, this is an expand operation. And it's an expand operation going to onto server, yes, which is a server in Australia, which is one of the companies that were developing this demo in the original time. Yes. And if I explore all the different parameters, I think it's best shown here. We have a URL, yes, and then we have an ECL. You can see here that says ECL. Yes, if I grab this, let me show you how this is constructed. So URL. Okay, so I will paste this here. I will decode, and if you see it below that is decoded, you see you have the file server up to here. You have the value set. Let me make it bigger.
Alejandro, try to make it bigger.
You have the server.
Can you hear me, Alejandro?
The value set resource, the expand operation, the URL of the SNOMED version. So it's the standard SNOMED version available in the server. Then we are using an implicit value set, FireVS, and the value set is defined with an ECL. And the ECL is descendants of clinical finding, procedure, and all that. And then we have a limit to the number of results we want to have, only 20 results, and then we have a filter. Yes, so you will see that if I open this in the new tab, this is the response we get. Let's look at the JSON. Yes, we get a response that contains a value set. The value set has a header. And then it has a contains. And the contains has all the matching things. So instead of 20, I will ask for counts to 2. And I go to the JSON. I see only 2 results. Yeah, so this is how it looks at the response. This is a typical Fire resource for a value set with the contains. You have the total count here, but the total is here, and you have the count of elements in the set that you retrieve. So the interesting here, and you will see when I type here, you will see how the expand operations appear. So when I type in diagnosis, let's say this patient has abdominal pain, and I would say this has an appendicitis. So I type append, and I get the first option I get is appendicitis. Yes, because it's the shortest one. That's also not only the matching, but also the sorting. There's a best practice for how to sort many results, and the recommendation is to put the shorter results first, because you are matching by substrings. So the shorter ones are more similar to the terms that you typed. And so it's actually really effective, and it works really, really well. And you see, when I did that, I get another call to the server. And when I go to procedure, I do append the same search term, but in this case, I get appendectomy. I get a different result. And this is because these 2 operations have the same filter, this one and this one, have the same filter, but they have different, same filter is append, but they have different ECL. One is looking at all the diagnosis, and the other one is looking at all the procedures. And I think if you have to take something from the implementation of SNOMED in the clinical tools, it's this part that Anne already discussed before. No, Anne, I can't hear you. Oh,
you can't hear me.
Let me see.
Can you hear us, Alejandra?
Now I can hear you. Sorry.
Can you hear us?
My headset got off after a while.
Okay. I was just wondering if you could show doing a search sweeping server where you can see. So now we're connecting to onto server.
I was going to do that exactly.
Okay, good.
Yeah, exactly. That's the key. Well, I'm lost. Probably was talking above you. Sorry about that. Yeah.
No, all good.
I was saying that if you want to take one message from this is how using these restrictions in the span operation, the ECL, you can customize the content of SNOMED for each field. So you only show the content that is relevant for each one of these fields. And like Anna said, all these operations are going to onto server, yes? But if I click here and I switch to Snowstone and I look for the same thing, I've paid, I was up with the D, you get the same results. Yes, and if you look at the expand operation, it's really similar. It's just going to a different server, but it's doing the same value set, it's doing the same operation, and it's using the same parameters. Yes, so this is the way in which you save time, because you can switch from different companies, from different providers with different open source solutions. But your application is exactly the same because all the servers comply with the same.
Emma, do you have a question? No. Okay. I thought your hand was up. Sorry.
No, sorry. It's just because Alejandro can't hear you. That's why. Sorry.
Okay. Thank you.
Look at this. Not only for searching, for example, if I click in appendectomy, you see there are a few more searches so let's see. Once I click something like incision of the appendix, another searches are automatically performed. And these searches are, if you look into them, yes, they are expanding a particular value set. And this value set is this ID that is here. This ID, you're using a dot operation, etc. But these operations, what they are doing is trying to understand whether you need to expand the laterality option or not. For example, if I do, I will remove everything. I will search for breast excision. Excision of breast, yes? And these operations enable this field, right and left. And how this is done? Because we publish a ref set, a list of concepts that are parts of the body that are lateralizable, that can be defined with left and right. We publish that in SNOMED. Every time you select a procedure, this application is extracting from the procedure, is extracting the value of the site of the procedure. So in this case, it's extracting the code breast. So if I go to preview, if I go to expansion, contains 0, it's breast structure. Yes, so this operation is an ECL that extracts the knowledge that excision of breast occurs in the breast.
So you can compare this. Can I say you can compare this to the slide I showed this morning with the lung head or the X-ray of lung having a procedure side of the lung structure. So this query here is actually saying what is the procedure side of this procedure, excision of breast, and that's the breast structure. So that's how those properties are used at runtime. Yeah.
Exactly.
To find the structure. Yeah.
Exactly. If you want to see it in the browser, for example, let me see. Let's decode this to understand how it's done. So let's decode this to see it's doing this operation here. Yes, so if we go to a browser, and this is part of the ECL presentation that we skipped, but that we are going to do very fast in a few minutes.
I think it's okay to skip it and then just show ECL in the browser, because then we have time to just go to the mapping tool as well.
Oh, exactly. So this is an ECL. This is very basic. It says this concept dot descendants of this concept. Let's make it more readable. So I will look for this concept ID, excision of breast, the one I selected, and I copy FSN and concept ID, and I will replace it with a more, it's not copying. Copy FSN and concept ID, I will replace it like this. And then I will get this to see what it is, and this is an attribute name. This is a procedure
Just drag
site
it
attribute.
over. You can just drag it over.
Yeah, you're right. But it will have to delete one. 3 up there. Good. So if this is more readable now. Now we're saying if I use only that, I will remove that. This is a valid ECL. If it's the name of a concept, I get only that concept. But when I add the dot operation says, give me the values of these properties. And the properties are the procedure site properties. And there are more than one procedure site properties. If I go to procedure site, I see I have procedure site direct and procedure site indirect. So by using this here, it means that give me the value of procedure site or procedure site direct or procedure site indirect. Because if I do only this part of the ECL, sorry. If I do only this part, I get 3 codes, procedure site, direct, and indirect. When I do a mix of these, I will get the values. When I get the values, I get breast structure. Yes, and this is how ECL works. And this is how we are using ECL in this demonstration to understand what's what is the organ that this procedure is occurring into, the procedure site. And then if I copy this again and I go to decode, and we'll see the second ECL that is running automatically. Sorry, I missed it. Copy URL. And decode, we see that the ECL is this one. I am lost in that one. Position of rest, and this is procedure site, and this is laterality. Okay, this is looking if this procedure site contains laterality. So when I execute, I get side. Because if I get these, I know that there's a concept in the terminology that contains a possible lateralization for that procedure site. And that is what enables or disables the field. Yes? So this is just to show you how it's agreed. So if I have excision of spheroidectomy, this laterality is disabled because there are no left spheroid or right spheroid in the terminology. So yeah, that was a bit detailed, but that's how it works. But let me show you other examples. And the other interesting example maybe is the allergies demo. And the allergies demo is something that was created with the allergy CRC in SNOMED. So if you go to the implementation guide, this is a document that was created by allergy experts in the SNOMED community they also work in defining the representation of allergies in HL7. I think no, it's not there anymore. It's the docs in SNOMED.org. And if we go to implementation guides, and we go to the clinical implementation guides, allergy implementation guides. So this document is a document that contains how allergies are represented in the SNOMED use cases. All the implementation guides you will find have clinical use cases and then the content in the SNOMED that covers the use cases, and then information about the terminology bindings, and then some implementation considerations. So you can read about it here. And you can see it working in real time here. So this on the right, you see standard file resource. On the left, you have the operations. And if I open the console, you will see all the operations below. So if I look for an allergy, like for example, aspirin, I'm looking at the propensity. Yes, so allergy to aspirin, and you see how many queries are being started. And each one of these queries is an expand operation with different values. Yes, so just using expand, we can get that if you have aspirin, aspirin is a kind of hypersensitivity, allergy to aspirin. And it's the substance that is the focus on the causative agent of the allergy is called aspirin. And the type of substance is a medication. The substance category is a medication. If instead of that, I do like shrimp, allergy to shrimp, and I select that, the substance moves to food. And how do I obtain that? Because one of these ECLs is searching at some key groupers in the terminology and saying whether this is a medication or a food or some other thing or an environment thing or something like that. Yes. And also if you do some intolerance, like intolerance to milk, this says food, but it changes from intolerance to substance instead of hypersensitivity. Yeah, so each time you select something, you can see how the representation in Fire changes, but also some ECLs are run automatically below to support your representation. For example, in this case, this is a field that contains a clinical finding. If I click here, this is related to clinical finding because what I'm searching is the manifestations. Let's say you have an urticaria for this, yes, and then you have moderate sensitivity, and then you have the root. And if I click here, these are all the concepts that are related to the route of administration. So if I type here oral, yes, and you get the oral route from here. Yes, and this is how all this demo is powered by ECLs in the back, and each ECL is being executed using an expand operation. So when you look at the requests, are all the expand operations with different ECLs that you need to be creative and versed. Yeah, so let me show you Snap to SNOMED now that is related to all this, and we can take advantage of this knowledge. Yeah.
One point that is fair to mention now. So now you've seen terminology servers. We've talked about the FHIR terminology service, and it may be a lot to take in, like when you hear about SNOMED for the first time and how it works. But it's actually quite easy to set up the Snowstorm terminology server, and we have instructions on GitHub how to set it up, and you can start to play around with it. And I just want to repeat that we are happy to help you set it up and happy to help you get started, because once you have it, as you can see in Alejandro's demos here, it's a matter of those front ends, having them connect to the server, and then you can do all sorts of things. So, so don't hesitate to reach out to us if you want to learn more about this.
Exactly. Remember this site, the implementation portal is really good to summarize everything. The demos are here in Showcase Demonstrators. You have the demo site. In tooling terminology servers, you have the description of the most common terminology servers. Here you will have Snowstorm, the GitHub link, and you have Snowstorm Lite. Maybe we didn't discuss this, but and here are some commercial ones like Hermes, Onto Server, which is the one that we were showing in the demo, Fast, Semantic Kit, Snowray, and the one from WCI. Most of these are commercial, and this one is open source. And you have a Snowstorm and Snowstorm Lite. Snowstorm is a more powerful one. It has all the features, but it's more demanding on the resources that you need to execute. Yes, but Snowstorm Lite, it has a special purpose. So Snowstorm is this one. and you have all the documentation here. It's really easy to use. It takes some time to load a new terminology. So when you have a new release of SNOMED and you want to run it, you have all the documentation here. It says configuration guide, loading SNOMED. Here explains how to load SNOMED. Yes, this will take 30 to 60 minutes depending on the performance of your machine. Yes, let's say you can do it either via the command line or via an API, but you just upload the release files that you get from SNOMED. But there's another option for that is Snowstorm Lite. This one. Snowstorm Lite is designed to be really lightweight, to use a very small memory footprint and to respond really quick. The limitations are that in Snowstorm you can have many terminologies, like SNOMED and ICD-10 and LOINC, and they can all live inside Snowstorm. And from SNOMED you can have different releases, the French, international, the Canadian, the Belgian, and all live in the same server. Just you provide different URIs and you get different terminologies. This one is much more simple. It has a very single terminology, only for SNOMED and only for one version of SNOMED. But this is really quick. When you use Snowstorm Lite and you want to run it, in less than a minute you have it running. Yes, so it's really, really quick, and it's so quick and so lightweight in memory. Yes, after the index is created, it can run just 500 megs of memory, and it's so quick that you can have several instances of Snowstorm Lite to have different versions of the terminology, for example, if you want. So if you want something really quick and easy to use, maybe you should go to Lite. And if you want to have all the features, probably you should go to the main Snowstorm. And these are really, really simple to use. And then we want to show you Snap to SNOMED, which is our mapping tool. When you go here for the first time, you have the user guide, and you can request a new account from here. The use of this web application is completely free in member countries, so you can request that. So when you log into Snap to SNOMED, I'm already logged in. This is why it looks like this. You see all your mapping projects, yes, but let's create a new one to understand how this works. Snap to SNOMED is a mapping tool. It's used to link an existing terminology to SNOMED in a very simple way. Yes, and sometimes this is the first approach to SNOMED. When you have something that is already working, but it doesn't have SNOMED support, and you have your own list of terms for symptoms, for diagnosis, for procedures, or for medication, you say, okay, I don't want to change my system, but I want to have a SNOMED representation of the data. So what you can do is to map your vocabularies to SNOMED. And this is a very basic thing because you don't benefit from the size of SNOMED. SNOMED has a lot of content and is expanding every year. But if you use your local list, then you're not taking advantage of all these features. But if you have a SNOMED code, then you can share the information with someone else. You can use a SNOMED ECL for analytics. Having a SNOMED code in your system enables you to start using your information in a different way. Yeah, so it's really, really a great benefit. So let me help you how you will do that by creating a map. Anna send me something. Oh yeah, yeah. Let me use an example file. So, let's see a common. Let's do like my problem list map. Yes.
This is a way to just say, let's imagine that you had a value set in your system, maybe a drop-down list of some problems that you are recording. Yeah. And now you want to start your migration into SNOMED. And this, what Alejandro is showing, how you can actually use a tool to start mapping those codes that you have, your local codes, into SNOMED.
Exactly. And you upload this list. You click here. I don't think you see.
I don't think we see the file, Alejandro.
No, you don't see the file, but I don't see it either. Let me see where it goes, where it went. Why is that there? downloads. Save. Sure. Oh, it needs to be a TSV. It doesn't have to be an Excel.
Maybe you can see how it often looks in the spreadsheet, and then we can download it together.
Yeah, let's do that. I'm afraid of let's do this. Drive.
Just search for diseases. It's there.
Yeah, because project.
I think we have it there. You can just open it.
Yeah, file. Oh, we have it there. Okay. Fine.
Yeah, if you just do a search for common diseases.
Yeah, let's do it.
I thought so.
There, common substance.
Yeah.
Okay, this is a spreadsheet that we have there. So this has a code that is an internal code. And these are the name of the diseases you have in your system, for example. And you want to add a new column with the SNOMED code. When you do that, you're SNOMED compliant. It's the most basic possibility to be SNOMED compliant. So SNOMED has many other options to code, but you're restricted to this because this is your list. But still, when you have the SNOMED code, you can do all the things that we discussed.
This relates to the second option you showed, right, Alejandro? When you saw the three vendors, the one in the middle where you maybe store your local source codes, but you still want to also utilize the SNOMED.
Yeah, exactly. So I downloaded this as a TSV. So I go back to Snap to SNOMED and I say, let's use my. We have that. And I would choose the file that we just downloaded. Okay, this says that we have a code column, which is source code, and we have this display column, which is source display. Display is the term, it's the fire keyword for the term, for the synonym. So if I click and save, it has imported my list of codes. So I'm mapping my problem list vocabulary. This is my list of codes. Now I need to define the target. And the target will be, for example, the French edition of SNOMED. So French edition. And the last one we have in the tool is 2024. The tool is updated by request of the members. And then here it's an important part to say, okay, I will map my list to SNOMED French edition. And I will. I don't want to map any part of everything in the SNOMED French edition. I want to restrict the possibilities to the real part because this is a problem list vocabulary. I want to only match the clinical finding hierarchy. These are a set of common used hierarchies like clinical finding, and when you select that, you get an ECL below. So the ECL is working as a restriction for the map. To say, I will only map my problems to this hierarchy of SNOMED, to the clinical findings.
So this is a way that we use a terminology server to help us avoid any bad maps. We want to make sure we only map to clinical findings. So that's really what we say here. If you had a list of procedures, you would restrict it to only procedures so that you don't accidentally map to something wrong.
Exactly. I have added Anne as a collaborator, for example. So we will both work together on this map. This is an effort that will take some time, depending on the length of the map. So we want to go through it, yes? So in this case, I have all the terms in my system here. So what I will do is create the first task that is the map task. Yes, so I would say assign to me as an author all the concepts. So I need to create the maps myself. Yes, and then I can create a second task, which is a review task. I can say, please review, and I would say I will send to Anna as a reviewer all the terms. Yes. So now this tool is allowing me to work as a team. Yes, and for all these concepts, I'm the author and Anna is a reviewer. Yes, and this will give me the possibility to go through all these things and produce a map that has some kind of validation, because to persons were trying to validate this. So when I click on my task, I select the task from here. I have this task that's called map, and I've been assigned to map the 25 concepts. And I can go one by one if I want. I can click here on the actions. I can start mapping. Okay. This will automatically perform a search. So heart disease that has the code D1 in your system, yes, matches to all these by similarity. Let's say this is similar. This looks really like the same thing, a disorder called heart disease. So I can grab it and drop it into equivalent. Yes. And when I drop it there, I can say
the details of the concept to the right.
Yeah.
Far to the right. You have the target, the structure of heart. You can see
the properties and the location of the hierarchy. Heart disease is a kind of disorder mediastinum. It's the parent of acute heart disease. I can pick one of these if I want, like this one. Yes, but this one looks like the more similar one. So I can leave it as a draft if I have some doubts or questions. I can say, okay, this is mapped, and I go to the next one. Yes, I will go back to the list. Because this is mapped already, probably Anna already has it for review, for revision, and she can approve it if she wants. Yes. So this is how we work as a team. But also, when I go to my task, yes, I can say instead of doing this one by one, let's click on automap. Instead of clicking this, if I run automap, this will look for similar things in the terminology. Yes. So for all these, we can see how it was automatically matched. For example, hepatitis B is called viral hepatitis type B. So kidney disease, influenza, pneumonia and influenza, diabetes, Brown's diabetes. This is a problem, yes? So here I can do my revision much faster. Like cancer, this one I can put to mapped, and I say this is equivalent, for example, or for Alzheimer's disease, I can say the same. But when I go to diabetes, I realize that actually I need to fix it. So I go to, where is diabetes? Here. I can click here and I say diabetes. Actually, diabetes mellitus. This is the one that we want. And I say this is equivalent. And we remove the wrong map. Yes. And then we make it mapped and we continue with the next one. And we can continue the revision. So when I do all these things will be sent to Anna for revision. Or this is an intentional injury, so I can look for the map and things like that.
I will only be able to see the ones that have a status of mapped. So when I go into my system, maybe I should try to share and see what I show.
You want to share? Yeah.
I can show what I see if you want.
Yeah, please. Yeah.
So what you can see here is that if I go home, the last one I just have is the one that Alejandro created and he added me. And when I go in here, I see everything, but as soon as I select my task, you can see the please review. I see the things where, or I can see everything, but the places where I'm able to do stuff is here. And then I can say that I accept or I reject. I can also go in and say, add a note if I wanted to, say something to Alejandro, this is good, or have you thought about maybe using this concept instead? I could drag it down. I could save a note. So this is a way for me just to say accept, go next, and so forth. Back to you, Alejandro. We always recommend that you don't start to map in a spreadsheet, but that you always use a tool, because this one is it supports that you can go into. You don't hear me?
Yeah, I was just feeling it saves you a lot of time to have a tool that make the automatic mapping and.
Yeah, it saves. Yeah, and it also saves errors, because if you work in a spreadsheet, right, copy paste errors And I think what is really, really beneficial, I don't think we have time to show that, is that you can create a new version. So when there is a new version of an international edition or the new version of the French, you don't just go in and edit your map, you create a new version of the map. So similar to how we manage concepts, you can also make sure that you don't start to delete stuff in your own implementation artifacts, but you have them for traceability, and then you just have a new version of your map. I think we lost Alejandro. Did we lose you, Alejandro? He will reconnect, he says. But I think that is really an important thing. And then if you create a new version and you have mapped to something that was inactive in a new version of SNOMED, it may be that the diabetes mellitus concept was inactivated and replaced by a new thing. Then the system will also suggest what things to map to. So this is really making updating value sets and stuff a lot easier. While Alejandro reconnects, I can just share again and show you.
And if you were not here this morning, so Alejandro just show you, you can select the French edition. So we had the 2024 edition, but as we are not on the, we are not distributing SNOMED CT through the MLDS, but through the ENS SMT. The link is not automatic, so we are working with SNOMED to be sure that at each time we will distribute or publish a new version of the French edition, it will be available on the Snap to SNOMED.
Yeah. And here you can see when I create a new version, I would, if we are up to version 5, then you can go back and see how did the map look in the first version and so forth. There is a feature here, which is the export feature. So there you can just export it as a new spreadsheet. Let me just do that and show you that. So here you can see that it simply exports the table that we saw there. So you have the target ones here. The reason you can also flag something as being unmapped, like unintentional injuries. We don't have a concept in SNOMED to match that, because unintentional injuries is a pretty ambiguous term. So this is also, when you flag something as unmapped, gives you an opportunity to maybe discuss internally what to do about those kinds of terms. Maybe you want to improve it, or maybe you need to create a concept in your local national extension or something. You can also export, as you could see here, to FHIR. So this would be a FHIR concept map that you can import. Yeah, it's not rendered very well in this textastic here. Maybe I can. I should be able to format it easily to JSON. I can't do that now. But nevertheless, this is the JSON format that could be imported into a FHIR terminology server as a concept map. Yeah.
We can't see the file.
Oh,
we are
you
only
can't
seeing
see
the Snap to SNOMED screen.
Okay, sorry. Good. Thank you for interrupting me there. Maybe I can do this. No, that's the wrong thing. Maybe I can do. I don't know how to do it, Mael. Well, what I saw there was, it's just a really messy JSON representation, because it wasn't even structured, but it's something that can be loaded into your terminology server. You can entitle it, and then just using the standard FHIR terminology services, as Alejandro was showing, you can expand it.
Translate operation, yeah.
And you can use the translate operation. Hi, Alejandro, and welcome back.
Sorry, my microphone disappeared sometime.
No, that's good. I think so. I'm pleased that we managed to show you Snap to SNOMED, because you can enroll there today, and you can get started just playing around with this. And there are user guides that can help you with videos. So just to try doing it. Yeah.
Sounds good. I think the last thing we have, maybe because we have like 15 minutes, is the, or no, less even, the versioning part, right? I don't want to, we can do very quickly the versioning part. Yeah.
That's good. Yeah, very good.
Let's do window, this one, share. The importance of SNOMED, how SNOMED is used, how it's integrated, and how you can use it from the FAIR API. Yes, how in the case you're maintaining a database of SNOMED in your terminology server, either you're using terminology server directly, or you're using the terminology server to populate your tables, and you're using the tables, extracting values. So there are many ways. But there's a challenge that SNOMED is really active. Yes, SNOMED is being released. If we go to the browser and we go to the international edition, the latest version is from November 1st, and you have one from October, September, August. It's monthly release in the international edition. Yes, when you go to the French edition, you have less update, but still, compared to all the terminologies, it's a lot because you have one every year or every 2 years. When you see things like ICD-11 that or ICD-10 that changed very few times in a decade, this is really, really new. Okay, so the challenge is maintenance, how you get updated to SNOMED. So SNOMED is being updated really quickly to evolve with the terminology. There's a life cycle, there's a big content team that gets requests from the national members and from projects, and they create new content that is published in the SNOMED CT. Yes, so the concepts are created for a particular purpose, they live, and sometimes because science changes or priorities change or an error is discovered, these concepts may be inactivated. When a concept is inactivated, it doesn't go away from terminology, it's still in the terminology, and this is called the graceful evolution. And this term graceful evolution comes from Cimino Desiderata, which was a big research paper in the 90s that described how terminology should be designed for the 21st century. And terminologies need to be flexible, need to evolve, but when they change, they need to maintain all the history. So the users can track all the changes and understand why things happen. Yes. So when you do that, every time something is inactivated in SNOMED, the concept that is inactivated is pointed to new ones. If a concept is inactivated as a duplicate, it will come to point to the other concept. And if something is inactivated as an ambiguous concept that may have two meanings, it can point to two. And these relationships are qualified. For example, deformity of pelvis has been inactivated and is possibly equivalent to deformity of the pelvic region or deformity of the bone of pelvis. Yes, because pelvis per se can refer to the bone or to the region. So this was an improvement of the terminology, but if you use this concept, you need to understand that maybe one of these are relevant for you. All this information is stored in these incremental updates. Yes, so every time you get a new release, you get a new file that contains the concept, relationships, and descriptions. Everything in the file contains an effective date and an active flag and module identifier. So if something gets inactive, the active flag is turned to false, and the module identifies who is making the change, who has the ownership. Yes, and if you have many states for a concept like being active, inactive, active, inactive, those states can be ordered by the effective date. Yes, so in this case, you have a concept that is active in 2002 in the first line. And then you have a description that is active in 2017 or relationship that is active in 2008. Yes, but when you have a new release, everything is recorded in that format. You will have a new row that contains all the information you need. Remember that SNOMED is making all the content available. Yes, and the best way to do that is to rely all that on the terminology server, because the terminology server will automatically get you a snapshot of the latest status of everything. You don't need to be burdened or complicated by all the previous states. When you put the package in the terminology server, you get automatically access to all the terminology servers, but also you get access to the to the history operations, because when I go to the ECL tutorial, there's one part at the end that maybe is interesting to know, that is the history supplements, yes? So the history supplements is a way in which you can retrieve the content that you saved using old concepts. Yes, in this case, allergic infective asthma is inactivated, but when you want to look at that, because we have all this information about whether it was a duplicate, it was ambiguous or something like that, when you use this kind of thing, like plus history min, what you see here below, this operation, this is like a modifier of the asthma. It says, give me all the descendant of asthma plus all the history, plus all the inactive concepts that today point to asthma. And when you do that, you can do an operation over the information recorded in your system. And you will not only retrieve the active ones, but also the inactive ones. And this is useful not for recording, but when you want to do analytics, for example. When if you are maintaining history for a long time in SNOMED CT, maybe 5 years ago, you recorded with a concept, and now the concept is inactive. So when you say, give me all the kinds of asthma, that inactive concept will not appear anymore. But unless you put that, when you put the plus history modifier or supplement, you start to get all the inactive ones. And when you are looking into your historical record, that's really useful too. So those concepts that are inactivated don't lose their meaning. They are still retrieved based on the historical associations recorded on the SNOMED release. Yeah, so that's basically what we wanted to show you. And also just one more thing, in the demo site, you have one demo that's called SNOMED CT as an evolving terminology. That, for example, you can see the inactivation reports. You can see how many concepts are inactivated on each release. And if you want to see this year, for example, in November, there were 150 concepts inactivated with different reasons. For example, these are outdated, and you can see what inactivated Philadelphia parasitica that is now called Phacochromium parasiticum. And this is probably an organism naming change. Yes, but you have a few that maybe are like voice tremor group has been replaced by voice tremor, for example, or things like that. So you have all this information about the historical changes, so you can know how often things change, and you can be prepared to understand the reasons. Yes. Okay, I think we are on time, right, Mal? Questions?
I think maybe we can just show a few things. Can you, Alejandro, if you just steer, you have listened to a lot these past hours, and so tomorrow when you wake up eager to learn even more about SNOMED, I want to just show you a few places to go. We have a document library, so all the documentation. So if you go to docs.snomed.org, if you go to docs.snomed.org, the website you see here is our document library. And if you scroll down here, Alejandro, all of our documents are available here. It's a long list, but you could, for example, go to the implementation guides. That's where you can find, for example, and then take the other code systems. One of you asked about lab and SNOMED, and a place to go could be to go to the LOINC implementation guide and learn about how the LOINC ontology works, the different use cases, and how to apply that extension to SNOMED. We also have a demonstrator that shows you that. So that is one place. Another place could be the Terminology Services Guide, which is under Practical Guides. You have learned about terminology services today. It's under Functional. And there you can see. On the front page of the document library, there's also just a long list. So you can use that and just do a Command F to find what you're looking for. But this is the one where you can see all the different types of terminology services. It also introduces the fire operations. I think it's under terminology services types. get a concept, get terms for a concept, like what you would do, or find concepts. And then in the bottom, you will see the actual requests. See, so that is a good resource as well. There's also an extension or expression constraints guide. If you just scroll down, Alejandro, maybe you can find it in the list. Expression constraints. So that is the guide where you can learn all about the expression constraints that we have also spoken about today. And there are also
and this is the example section. I think it's the best one to learn.
Yeah, yeah. I would also suggest that. Go directly into the examples.
And you can copy and paste any of these. You can copy and you go to the browser.
Yeah.
And you just run it here.
You paste it. Boom. And then you will.
Yeah.
So you can use that guide in conjunction with the browser to learn about the language. So I really do recommend that. Then I suggest that you go to snomed.org/courses. So bookmark this documentation space, but also be aware that we have a set of e-learning courses. And because you are in France or in a French territory, then you can also access these courses for free. So you can see we have a foundation course that covers many of the things that you have learned today. So you will be very pleased to know that now you are not in the beginner or beginner level, or as you were indicating this morning, now you have moved to a more advanced knowledge level, which is great. And once you have completed the foundation course, you can go into the implementation course. And that is an excellent course to use as a lookup. You don't have to complete it from A to Z, but you can learn about terminology services and search and data entry and expression constraints, anything in the implementation course, and just use it as an interactive platform. So I recommend that as well. Yeah.
You can do this course by dependent models, right? Exactly.
Yeah. The last thing I think we should do is to, as we started this morning, so if I take the screen, Alejandro.
Yeah, please.
I want to just evaluate the sessions we've had so that next time we meet, we can learn from your feedback. So if you go into ahaslides.com, 1HAVF, I'll just put that in the chat. Can I do that? Click, copied. Okay, maybe I am. Yeah, I'll put the link here. So I would like to, or we would very much like to hear how satisfied you are with the session today. There's only 3 questions. I promise we won't bombard you with stuff, but it's just important for us so that we can learn from you. We will look at this. We will look at them. I think you should just run it as you go along. And we are not offended at all of any feedback we get. We really appreciate you giving us the opportunity to speak and to learn from you. And then maybe I can just on another screen just move to, what do you see now?
I see a blank screen yet still.
Yeah.
What do you see?
Nothing, like a blank screen.
No, we are saying slide results.
Yeah, yes.
Oh, I see.
You're seeing the slide?
Yeah.
It's me then.
Okay. Okay. I see why it's a bit annoying that I'm showing this as well. But I also want you to answer the next question about what you enjoyed about the webinar, and also what we can improve for next time. So I really hope that you will go into this, and I will stop share here. and then go into this aha slides and give us your feedback. That would really be wonderful. Yeah, Maëlle, Elizabeth, do you have something you want to say before we end today's session?
Yeah, first of all,
Thank you very much.
Yeah, thank you both of you for being there. We hope that you learned a lot, and as Anne and Alejandro said, don't hesitate to reach to them or reach to us. You had the email from the implementation, and we can put our email too. If you have any question regarding SNOMED or any other terminologies. And yeah, well, thank you everyone. The replay and the slide will be shared, and we hope to see you next year with new webinars. And then Alejandro.
Yeah,
That's
we look
great.
forward to
Yeah,
that.
thank you very much. It was really inspireful because you show us concrete use of SNOMED CT and the implementation. So, and the use cases are really very ergonomics. So,
Yeah, I think
thanks a lot.
Thank you. Thank you very much.
I know we show best practice principles, and maybe you're sitting there and thinking, "Oh, we are not at all ready for this." But there are also, I hope that you also know this out there, that you can also go with less. Like you can start to create small sets and integrate them. You don't have to go with the terminology services immediately. You can build up slowly. Yeah.
And thank you very much for your support and for all the French ecosystem, because it's really useful for us to learn and progress on the SNOMED CT road.
We all learn something new every day in this journey, and if we go together, it will go better. So that's good.
And every year we present this is a bit simpler. Every year we have a new tool that resolves some implementation issues. So
yeah,
you will see that it gets simpler and simpler with time.
Yeah, fortunately.
Yeah.
We'll end up being standardized in the ecosystem, e-health ecosystem, and that's where we are targeted.
Yeah.
Good. Thank you everybody for attending.
Thank you.
Thank you.
Merci beaucoup à tous pour votre participation. Et comme le disait Maëlle, n'hésitez pas, si vous avez des questions, à revenir vers nous ou Anne, bien sûr, comme elle le proposait, Alejandro et Kai. En fait, qui aura l'opportunité de présenter le By Me Project. Et voilà, puis merci vraiment d'avoir participé et d'avoir eu de vous intéresser au sujet. C'est vrai que c'est important.
Bye bye everyone.
Merci.
Bye bye.
Bye.